Welcome back. I'm Ranga Karnam and I'm excited to be your instructor for this course. Azure has more than 200 services. This specific exam, AI-900, expects you to understand 20 plus services related to artificial intelligence. You are expected to know services like Azure Machine Learning, Cognitive Services, Text Analytics, Speech, which are related to artificial intelligence. This exam tests your AI fundamentals and also your decision-making abilities. Which AI or ML service do you use in which specific situation? This course is designed to help you make these choices and learn about the different AI services in Azure. Our goal with this course is not only to help you get AI-900 certified, but also to help you understand the fundamentals of artificial intelligence and implementing artificial intelligence solutions in Azure. We want you to be able to take the knowledge you gained in this course and apply it in your real-world projects. Now, what is our approach to building a great course? We are taking a three-pronged approach. We have amazing video presentations where we would introduce the different Azure services to you. We also have designed a number of amazing demos where you'll be playing with the Azure services. We also have two different kinds of quizzes to reinforce your learning. We have the traditional text quizzes where you have questions, multiple choice answers, and you pick the right answer. We also have video quizzes where we discuss the scenarios, solutions, and the different variations that are possible on the solution. By using this three-pronged approach, we think you'll be able to remember things for a long time and you will do really well at the exam. Now, before we move into the next step, there are a couple of recommendations for you. Number one, this is not a race. Take your time, focus on understanding things well, and do not hesitate to replay videos when needed. The second, but the most important recommendation is to have fun. Preparing for certifications can get really boring, and that's why we have invested a lot of time to try and make this course really interactive, really hands-on, and making sure that you will have a lot of fun while you learn. I'm really excited to help you get Azure certified, and I'll see you in the next step. Welcome back. In this step, let's get started with an introduction to artificial intelligence. Artificial intelligence is all around you. Not a day passes these days without a mention of self-driving cars. You might even be owning one. Your email boxes use spam filters. The spam filters are based on artificial intelligence. They can recognize whether an email is spam or not. Gmail provides automatic email classification. It automatically classifies emails into primary, social, and promotions. This is also based on artificial intelligence. Fraud detection is also based on artificial intelligence. Whenever you do any transaction using your credit card or debit card or any online transaction, there is a fraud detection algorithm which is running in the background. Most of the times, these fraud detection algorithms are based on artificial intelligence. Now, you might be wondering, what is artificial intelligence? How is it different from the normal programs we write? Let's get started with a definition of artificial intelligence. This is the Oxford Dictionary definition of artificial intelligence. Artificial intelligence is the theory and development of computer systems that are able to perform tasks normally requiring human intelligence. Examples are visual perception, speech recognition, decision making, and translation between languages. Humans are really intelligent. The goal of artificial intelligence is to build computer systems that are as intelligent as humans. The goal is to build systems which can look at images and detect objects, which can look at videos and recognize what he or she is speaking about. To build computer systems that make as complex decisions as a human can make. To understand further about AI, let's dig deeper into the two different types of AI. The first type of AI is strong artificial intelligence. This is also called general AI. The goal of general AI is to build machines which are as intelligent as humans. A machine that can solve problems, learn, and plan for the future. A machine that is an expert at everything, including playing all sports and games. A machine that can learn like a child, building on its own experiences. And the fact is, we are really far away from achieving this. The estimates are that it might take a few decades to never. Some of them predict that we will never be able to achieve strong AI at all. All the typical AI examples that we look at are examples of narrow AI or weak AI. Narrow AI focuses on a specific task. Good examples are self-driving cars. They focus on driving safely. Virtual assistants. They focus on understanding what you're speaking and executing a few commands. Other examples are programs that can process an image and detect what is in an image. For example, in this specific image, we are predicting that it has water, it has sky, there is a lake in it. The picture was taken outdoors. There are skyscrapers in here. And you can also see that each of these is predicted with a certain level of confidence. We are also generating a description for this specific image, a city skyline with water, 27% confidence. This is an example of narrow AI again. This specific program can look at an image and predict what's in it. Machine learning is a category of narrow AI which focuses on learning from data, learning from examples. If you want to build a model which would predict what's in an image, the approach we would take to build such a model is to use thousands of examples or millions of examples with images and tags. You would have millions of such examples with predefined tags. You train a model using these, and later you will use the same model to predict what's in the image. This approach is called machine learning, where you are learning from data, learning from examples. In this step, we talked about artificial intelligence and we looked at the two types of AI, strong AI and narrow AI. The goal of AI is to build computer systems that are as intelligent as humans. And that's the goal of strong AI or the general AI as well. Achieving general AI is a long way away. Whatever AI we see in action today is narrow or weak AI. These solutions focus on specific tasks, self-driving cars, virtual assistants, identifying objects in an image. Let's talk a lot more about AI in the subsequent steps. Welcome back. In this step, let's look at a couple of examples of machine learning. Let's get started with identifying objects from images. The service in Microsoft Azure to help you to do that is called computer vision. Let's see what are the things that computer vision can do for you. The first thing that we look at is to analyze and describe images. It helps you to tag the content of the image, give a written description for the image, and also to identify if the image contains racy or adult content. Let's look at an example. Let's pick up one of the images from here. I'm picking up the second image which is present in here. This has buildings, roads, cars, and a lot of other things. And you can see that the tags associated with them identify that this is outdoor. There are skyscrapers in the picture. There are buildings. There is a road. It's downtown. There are cars in the picture. And you can see that there are a number of other tags that are associated. It also provides you a description about the image, a street with cars and buildings. It also says the picture does not have any racy or adult content. So you can see that each of these tags, description and racy content or adult content is associated with a specific amount of confidence level. If I click next page and select an image next, you can see that this can identify characters from an image. This is what is called optical character recognition, OCR. This is able to detect text in an image and extracts the recognized words into machine readable character stream. Similar to that, it can also identify handwriting in an image. Let's pick up one of the images from here. So you can see that from this image, it is able to identify that this is the transcript. So you can extract handwritten text from notes, letters, essays, whiteboards, and a wide range of other things. Let's do a next step. And let's look at the next feature of computer vision, which is recognize celebrities and landmarks. This feature recognizes 200K celebrities and 9,000 landmarks from around the world. Let's pick up Statue of Liberty. You can see that it says it's Statue of Liberty with 95% confidence. Let's say try another image and pick up Satya Nadella. It says it's Satya Nadella with 100% confidence. You can see the power of these systems. Now, the important thing to understand is how are these systems built? How is this specific model built? The way this specific model is built is through examples. Millions of images with the right tags, labels, and descriptions were used to train the model. Once the model is trained sufficiently, it can start predicting. Let's look at another example, AlphaGo. Go is a game which originated in China over 3,000 years ago. And winning a game of Go is very, very complex. It needs multiple layers of strategic thinking. An astonishing thing about Go is the fact that there are 10 to the power of 170 possible board configurations. As it says in here, it's more than the number of atoms in the known universe. So Go is Google times more complex than chess. We have been trying to write Go programs for several decades. And in spite of that, the strongest Go computer programs could only play at the level of human amateurs. And that's where AlphaGo comes into picture. AlphaGo is the first computer program to defeat a professional human Go player, the first to defeat a Go world champion, and the strongest Go player in history. There are multiple levels of AlphaGo, but the interesting thing is how AlphaGo was built. Let's look at one of the specific versions of AlphaGo, which is AlphaGo 0. AlphaGo 0 uses a novel form of reinforcement learning, in which AlphaGo 0 becomes its own teacher. The system starts off with a neural network that knows nothing about the game of Go. It then plays games against itself, and that's how it learns. As it plays multiple games, the neural network is tuned and updated to predict moves. The graph in here shows the ELO journey of AlphaGo 0. It starts with zero knowledge of the game and only the basic rules as input. It starts playing against itself. And within 3 days, it's able to surpass the abilities of AlphaGo Lee, the version that beat the world champion in 4 out of 5 games. And within 21 days, it reaches the level of AlphaGo Master, the version which defeated the world champion in 3 out of 3 games. And look at what happens in 40 days. It surpasses all other versions of AlphaGo and becomes the best Go player in the world. The important thing is that it does this entirely just by self-play. There is no manual intervention involved. In this step, we looked at a couple of machine learning examples, identifying objects from images and AlphaGo. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's dig deeper into the differences between machine learning and traditional programming. The traditional programming is based on rules. You would have a number of rules saying, if this, do that. If you want to predict the price of a home, for example, you design an algorithm taking all factors into consideration. You look at the location, home size, age, condition, market, economy. You take the different factors into consideration and you design a complex algorithm that would try and predict a price. The entire effort typically is very manual, and the system would be really, really complex because there would be a number of rules like this. On the other hand, machine learning is all about learning from examples. It's not about rules, it's about examples. You would provide millions of examples and you would create a model using these examples. Once you have a model, you can use the model to make the predictions. If you want to predict the price of a home using machine learning, you would gather a lot of data. You might gather millions of rows showing information like this. What is the home size? What is the age? What is the condition? And what is the price? Once you have lots of data, this is also called data set. You would use the data set to create a model. Once the model is sufficiently trained with right examples, you'd be able to use the model to make predictions. However, there are a lot of challenges associated with developing models using machine learning. You need a lot of data. The number of examples which is needed is huge. Availability of skilled personnel is another important challenge. There are not sufficient number of data scientists available. The other important challenge is the complexity in implementing ML ops. It's not like you build the model one time and use it all the time. The model needs to be updated regularly, and the process of updating the model is very complex. And that's what you'd be learning in this specific course. In this course, you'll be learning 3 different approaches to building AI solutions in Azure. You can use pre-trained models which are provided by Azure. An example is Azure Cognitive Services. Azure Cognitive Services can help you to get intelligence from text, images, audio, video. It can look at an image and give you the tags. It can take your audio and give you a transcription of that specific audio. It can look at a video and identify the person that's there in the video. So that's approach 1, using the pre-trained models which are provided by Azure. The second approach is to build simple models of your own without needing data scientists. Most of the times, developers have very limited experience with machine learning. And that's where these limited or no code experiences of building models become really useful. A good example of a service in Azure which helps you to do that is custom vision. Let's say you're running a specific type of industry where you'd want to identify the machine parts. The pre-trained models which are provided by Azure might not be able to do that. And that's where you'd need to build your own models. If you're using custom vision, you can say these are the images and these are the tags associated with the images. And you can train the model without using any code. Similar to that, Azure Machine Learning Service also provides you with an automated machine learning feature. So the first approach is to use pre-trained models. The second approach is to build simple models without using code at all. The third approach is where we would build complex models using data scientists and the large machine learning team. This is where you build your own machine learning models from zero. You'd go for this when your team is really experienced with machine learning. Azure Machine Learning also enables you to build complex models. So the 3 approaches to building AI solutions in Azure include pre-trained models. This is where you would be making use of the pre-built models which are provided by Azure through Azure Cognitive Services. The other 2 approaches involve building your own models. If your team has limited or no code experience, you can build simple models using custom vision and Azure Machine Learning. If you have an experienced team with data scientists in it, you can also build complex models, and Azure Machine Learning would simplify a lot of processes that are involved in building complex models. So as you can see in here, Azure Machine Learning can be used to build simple models as well as complex models as well. We will discuss the details of each of these services in the subsequent steps. We'll talk about Azure Cognitive Services, Custom Vision, and Azure Machine Learning in depth. In addition to learning these 3 approaches, we'll also help you to understand why it is important to use AI with caution. We'll help you understand the challenges, risks, and the important principles that you need to adhere to when you are building AI solutions. The goal of the last couple of steps is to give you an introduction to machine learning. Let's dive into the Azure solutions, starting the next step. Welcome back. In this step, let's look at a few scenarios related to machine learning fundamentals. You want to build a computer system as intelligent as a human. Something which is an expert at everything. Maybe even play all sports and games. Which category of AI are we talking about in here? We are talking about strong AI. This is also called general AI. You want to build a computer system that focuses on a specific task, either driving a car or detecting objects from images. What are we talking about in here? We are talking about narrow AI or weak AI. Most of the solutions that we would be building in this course fit into narrow AI or weak AI. The category of AI that focuses on learning from data, learning from examples. That's machine learning. How is ML different from traditional programming? Traditional programming is based on rules. If this, then do that. Programmers build a number of such rules, and your program executes them and returns a output. However, machine learning is based on examples. In machine learning, you'll use the data examples to create a model, and the model will do the predictions. Which Azure service helps you to use pre-trained models? There are a number of pre-trained models that Azure makes available to you under the umbrella of Azure Cognitive Services. You can do natural language processing. You can identify objects in images. You can detect people in videos using some of the services that are part of Azure Cognitive Services. Which Azure services help you build simple models without needing data scientists or AI ML skills? The answer to this is there are two important services. One is the automated machine learning feature, which is present in Azure Machine Learning. Automated machine learning helps you to build simple models without building anything complex like pipelines. The other option is when you are building image-based models. If you want to build your own custom model based on your own images, in those kind of situations, you can go for custom vision service. Which Azure service helps you build complex ML models. So you want your data scientists, your data engineers to work on really complex machine learning problems. Which Azure service should they use? They should be using Azure Machine Learning. Specifically in Azure Machine Learning, you can use Designer to create machine learning pipelines. Azure Machine Learning helps you to automate the entire ML lifecycle. As we go further in the course, we will learn a lot more about Azure Cognitive Services, Azure Machine Learning, and Custom Vision as well. In this step, we looked at some scenarios related to machine learning fundamentals. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this section, we would be talking about pre-trained models. What are pre-trained models? These are pre-trained models which are ready for use. These are provided through cognitive services. The goal of cognitive services is to bring AI within the reach of every developer. Not every developer is a machine learning expert. However, you'd want to be able to build applications which use machine learning. And that's what cognitive services enable you to do. It is AI without building custom models. It does not need machine learning expertise. And these services are exposed as simple APIs. These are exposed as simple web services. You can call this service and get the response back. If you want to find out what's in the specific image, you can pass the URL of the image as an input and you would get Statue of Liberty as an output from that service. You don't need to worry about creating a model, training the model, and deploying the model. You just call the API and you make use of the result which is provided back to you. That's what cognitive services enables you to do. It helps you to build programs that can see, hear, speak, search, and understand just like humans. You can get intelligence from images, videos. You can get intelligence from text. You can also get intelligence from audio. There are a variety of services that are part of cognitive services. If you want to get intelligence from images and videos, you can make use of computer vision, face API, form recognizer. If you want to get intelligence from text, this is also called natural language processing. You can make use of text analytics. You can use the translator API and the text-to-speech API. If you want to get intelligence from audio, you can make use of the speech-to-text API. Or there is something called LUIS, Language Understanding Intelligence Service. You can pass a sentence to LUIS and it would try and understand the intent, what you want to do. There are also a few other services that are provided by cognitive services. You can enable conversations. For example, if you want to build a chatbot, you can do that using something called Q&A Maker and the Azure Bot service. If you want to detect fraud transactions, you can make use of Anomaly Detector service. If you want to moderate content, if you want to see if a specific image has racy or adult content, or if you want to see that if any profanity is used in a specific piece of text, you can make use of the content moderator. The goal of this step is to give you a 10,000 feet overview of cognitive services. The goal of cognitive services is to bring AI within the reach of every developer. All these services are exposed as APIs and you can consume them from your applications. You can use cognitive services to get intelligence from images, videos, text, audio, and also to build conversations. In the subsequent steps, we will explore each of the services that are mentioned in here in depth. I'm sure you're having a wonderful time and I'll see you in the next step. Welcome back. Starting this step, let's look at the cognitive services related to vision. We'll start looking at the vision related APIs. There are multiple vision related APIs which are present as part of the cognitive services. Let's explore them in this specific step. Vision. It's all about getting intelligence from videos and images. Let's look at a few demos. This is a demo which we already looked at. So we saw that computer vision can be used to analyze and describe images. We can get tags, description, we can identify if it's racy or adult content. If I do next step, we can also identify text in a specific image. So this is optical character recognition in action. I can do next step in here. And over here, you can also read handwriting in imagery. So you can use optical character recognition to identify handwriting and also printed text in a specific image. If I do next step, you would see that I can recognize celebrities and landmarks in this specific image as well. So these are some of the basic things that you can do using computer vision. Let's look at another simple demo. In addition to tagging an image, generating a description out of it, you can also identify the objects in images. This is called object detection. You can see that if you give the image as an input, you can identify the different objects which are present in this specific image. You can see that this person is being identified. You can see that the train is also being identified in here. So you can see the different objects which are identified and returned back as an array. You can see that the object is a person. The coordinates of the person in the image are also returned back. The XY coordinates, the width and the height also is returned related to the person. If you scroll down, you'd also see details about the format of the image. What is the dimension of the image? Whether it's black and white, whether it's adult content, is it gory or racy? You can also get details about the color scheme of the specific image. Let's pick up another image from here. And you can see that the objects in that specific image are automatically identified. So in addition to tagging an image and in addition to generating a description from an image, you can identify the different objects and the coordinates of them in the image using computer vision APIs. Let's look at another demo related to videos. Over here, there are several videos. Let's pick one of them. Let's pick the one where Satya Nadella is talking. The UI is a little broken. If I scroll down, you can see who all are speaking in the video. So if you give video as an input, it can identify who are present in the specific video. So you can see that Satya Nadella is present 7 times, 22.50% of the video, and it also shows where he is talking, which points of the video is Satya Nadella appearing in. You can also see that another person is in the video. It's Sam George, and he also appears 7 times. If you click next, you can also look at the key topics that are being identified from the video. And you can also see where they are talked about. Let's pick up IoT Edge from here. You can see that there is a discussion about IoT Edge about 8 times, okay? And it is about 25% of the video. And you can see the specific points in the video where the discussion about IoT Edge happened. If I click next and go to sentiment and scroll down, you'd be able to see how sentiment changes throughout the video. You can see that there is positive sentiment at these parts of the video, and for most of the video, the sentiment is neutral. You can also see the key annotations which are present. You can see person, indoor, man. You can see floor, ceiling, computer, monitor. So these are all the times a monitor appears in this specific video. And you can also get a transcription of the video. So you can see that if I start playing the video, there is a transcription about whatever Satya Nadella is talking about in here. So vision related APIs help you to identify and analyze content within images and videos. Some of the important APIs include computer vision. This is used to analyze content in images and videos. Face API. If you'd want to detect the people who are present and the emotions of the people who are present in a specific image, you can make use of the Face API. In addition, you can also build your custom models using custom vision. Let's say you would want to identify the specific machine parts, or you have a use case where you'd want to identify the different types of clouds. I would want to identify whether a specific cloud is stratus cloud or cumulonimbus cloud or any of the other types of cloud which is present in here. In those kind of situations, I would need to build my own custom image model. And that's where I can go with custom vision. In this step, we got a 10,000 feet overview of the vision related APIs. I'll see you in the next step where we will talk about computer vision in depth. Welcome back. In the last step, we got a 10,000 feet overview of the vision related APIs. We saw a demo of few of the vision services and we talked about some of the important APIs related to vision. In this step, let's explore some of the terminology with respect to vision. Some of this might be straightforward. The goal is to review so that there is no confusion between the terminology which is which is used with respect to vision. Image analysis. Image analysis is all about extracting tags from the image and extracting a caption or a text description about a specific image. So you give an image and get the tags associated with it or get the text description about it. That's what is called image analysis. If you want to do image classification, what you are trying to do is to classify a group of images. It might be 10 images, 100 images, or 1,000 images. You have a group of images and you would want to classify them into different groups. One of the options you can use is to generate tags or generate categories from the image and use the tags and categories to classify these images. This is what is called image classification. For example, if you have a group of 1,000 images, you want to classify them into images containing vehicles and images that do not contain vehicles. So that's an example of image classification. We already looked at object detection. Object detection is all about identifying objects in a specific image. We looked at an example earlier where we detected a specific object in an image. Where is the cycle present in the specific image? For each of the objects in the image, when you do object detection, you get these details back. You get what type of object it is, what is the confidence level, and what are the coordinates of the bounding box. What is the x coordinate? What is the y coordinate? What is the width and height? Object detection goes deeper than image classification. Image classification is just to group images into different groups. In object detection, you want to go deeper. You want to identify specific objects in a particular image. Face detection is all about detecting human faces. It can be used for several use cases. For security, for tagging friends on Facebook, for validating identity of a specific person. These are all the places where you can make use of face detection. The other thing we already talked about is optical character recognition, OCR. This is to detect text in images. This can be printed text or handwritten text. Examples are if you want to find out text from a license plate or if you want to get text from an invoice. The goal of this step is to give you a high-level overview of the important terminology related to different vision services. Let's look into the specifics of each of the vision APIs, starting the next step. In a previous step, we learned that there are a number of vision-related APIs: Computer Vision API, Face API, and Custom Vision. In this step, let's focus on Computer Vision API. It is to process images and return information from a specific image. You can find documentation about all the APIs that are part of cognitive services in this specific link. When I navigate to this link, you should see all the documentation related to all APIs which are in cognitive services. And over here, if you search for vision and press enter, this is where you'd see the documentation related to Computer Vision API. You'd see that there are a number of versions related to Computer Vision API. What I would do is to use Computer Vision API v3.1, which is one of the latest that is available right now. If you click here and go inside, you'd land up on the documentation related to Computer Vision API. It is important to understand the hierarchy. In cognitive services, there are a number of vision-related APIs. And one of these vision-related APIs is Computer Vision API. This Computer Vision API provides you with state-of-the-art algorithms to process images and return information about these images. This specific API contains a number of operations. Analyze image, describe image, detect objects. These are all the operations which are present as part of the Computer Vision API. As far as this specific exam goes, you don't need to understand all the operations that are part of a specific API. A high-level overview is more than sufficient. Let's get started with one of the most important operations that is part of the Computer Vision API, which is the Analyze Image. The Analyze Image is the first one which is present in here. It is used to extract visual features from image content. What are the kinds of features that you can extract from an image? Can you describe an image? Can you provide a description or a caption? You can see that for this image, the caption which was generated is a city skyline with water. Can you categorize the image? What are the tags that are associated with this specific image? What is in the image? Identify objects, faces. Does the image contain celebrities or monuments? And also along with box coordinates. Understand where the specific object is present in the image. What type of image is it? Is it a clip art or a line drawing? What kind of color scheme is used in the image? Does the image have mature content? Does it have racy content or adult content? This is all the information that you'll be able to get when you use the analyze image operation, which is part of the computer vision API. In addition to the analyze image, there are a number of other operations which are provided by computer vision API. Some of them are very, very simple operations which include describe image, detect objects, recognize domain specific content, and tag image. These are very simple operations when compared to analyze image. Analyze image can provide you with a lot of details. However, when you want specific details, if you want just the description and a caption about a specific image, you can go for describe image. If you only want to do object detection, in that kind of scenario, you can go for the detect objects operation. If you only want to identify celebrities and landmarks, in that kind of scenario, you can go for recognize domain specific content. And if you want to generate a list of categories and tags that are relevant to an image, you can make use of the tag image operation. In addition to this, computer vision API also provides you with a get area of interest operation, which provides you with the most important area of a rectangle. Let's say I give it an image which only contains Statue of Liberty. Then the most important area of the image is Statue of Liberty. So it would return back the coordinates of Statue of Liberty. There is another operation to generate a thumbnail image. This is called get thumbnail. You can specify a width and height, and a thumbnail of that width and that height is generated for you. Now that we have a good overview of the important operations in computer vision API, let's get our hands dirty starting the next step. To be able to do that, we would need an Azure account. We will see how to create an Azure account in the next step. One of the important things to remember is that these demos are optional. If your goal is to just clear the examination, watching the demos should be more than sufficient. However, if you want to still get your hands dirty, you are welcome. You can join me and follow along in the demos that we would see later in the course. I'll see you in the next step where we would create our Azure account.
Welcome back. Are you excited to get onto the cloud? Let's get started in this specific step. The first step is to create an Azure account. And to create an Azure account, you'd need two things. One is your personal details, including your address. The second thing you'd need is a valid credit or debit card. Even though we would be using a free trial account, and most of the things that we would do in the course would fit into the free trial, Azure wants your credit card or debit card details. Now to get started, all that you need to do is Google for Azure free trial and click the first link which comes in. It would look something of this kind. Create your Azure free account today. Once you click that link, you'd be going to azure.microsoft.com page where you can click this start free button. Once you click that, you'd go into a sign in page. Over here, what you can do is you can say create an account. So you can click the link, create one, which is shown in here. Once you click that link, you can actually enter your email address on the next page. Make sure that you are entering a valid email address because this email address will be verified. Once you enter your email address, you can go ahead and enter your password. Once you click the next button on this screen, you would get an email. You need to enter the verification code from the email in the next screen. You should get an email which would look something like this with a verification code in there. You need to take this verification code and enter it in this specific window. After that, you can click the next button. You might need to go through a few captchas. Make sure that you enter the right values and you have an Azure account. Now we have to create a subscription so that we can get access to the free trial. And to create a subscription, what you need is all your personal details. So you need to enter your first name, last name, email address again, and also your organization details. Once you click next on this screen, you go to a screen where you need to enter your phone number and identify yourself. You get a verification code on your phone which you need to enter on the next screen. The next step is to enter your credit card or debit card details. Make sure that you enter the valid details and click next. Depending on the country you are in, Azure has different ways of authenticating your credit card and debit card details. Make sure that you go through those processes. Once you're verified, you should see a screen like this. In this screen, you can click the next button after choosing the right account. And on the next screen, you can read all the details about the subscription agreement, offer details, and the privacy statement. Read them, make sure that you're okay with them and accept them. After that, you can click the sign up. One of the things is this is quite a slow process, right? There are quite a steps that we would need to go through to get a Azure account. Actually, it makes sense because Azure gives you access to really powerful machines, and they want to be really sure who you are before they give you access to these machines. And that's the reason why the sign up process can be a little tricky. But the great thing is this sign up process is just one time. Once you go through this once, you'll never need to come back to this. Let's have some patience and you would see that you are ready to get started with Azure. You can click the go to the portal button to go to the Azure portal. The URL to the Azure portal is portal.azure.com, and you should see a page like this come up. If you'd want, you can actually take a tour of Microsoft Azure, or you can click maybe later and join me in the next step. In this video, we went through a number of steps to create a Microsoft Azure account. The process is a little tedious, but I hope you are able to get through it and you have a valid Microsoft Azure account to get started with Microsoft Azure in the next step. I'll see you in the next step. Until then, bye-bye.
Welcome back. In this step, we would want to do a demo of the computer vision API. If you have created an Azure account in the previous step, you can go to the URL portal.azure.com and log in with your ID. This portal that you are seeing in here is called Azure Portal. This is where you can create a number of Azure resources. In this course, we'll be playing with a number of machine learning resources. The first thing that we would want to play with is the computer vision API. And to be able to play with the computer vision API, we would go to cognitive services. I would say cognitive services in here. So cognitive services. So, let's close this and pick up cognitive services, which is the second one that you are seeing in here. So cognitive services, this helps you to build smarter apps and services. Cognitive services bring AI within the reach of every developer without needing ML expertise. You can make API calls to embed ability to see, hear, speak, search, understand, and accelerate decision making into your apps. Right now, we are focusing on the C part. We are focused on the vision part of it. If you scroll down, you'd see that there are a number of services in here related to decision, language, speech, vision, and there is also a multi-purpose service. All these things related to decision, language, speech, vision are single-purpose services. However, the cognitive services multi-service account helps you to add multiple cognitive services to your application. You just need to create one instance of this service and you'll be able to make use of a combination of a vision, speech, language, and decision services. So if you want to make use of the computer vision API, there are two options. One is go to computer vision API and create an instance of that. Or the other option is to go in and create a multi-purpose service account. And later, we'll be able to use the same account to do speech and other things as well. So what I would choose to do now is to actually use the cognitive services multi-service account. So what I would do is go here and say create. The first screen that you'd see is the create cognitive services screen. We are creating a multi-purpose account and this gives you access to vision, language, search, and speech cognitive services with single API key. With just one instance, we'll be able to get access to all these services. If you are in the free trial, you can choose the free trial subscription and you can go ahead and create a new resource group. As it says in here, a resource group is a container that holds related resources for an Azure solution. If you are creating a project, there might be a number of resources that are related to a specific project. You might need a database. You might need a compute resource. You might need a machine learning resource. You'd want to put all these resources as one group. You'd want to put all these resources in a single container. And that container in Azure is resource group. So I'll call this cognitive services RG. RG as a shortcut for resource group. And I'll say OK. So we're creating a new resource group. You can choose the default region which is recommended in here. And you can give a name to your cognitive service. I'll call this cognitive service in 28 minutes. An important thing to understand is that this will also be your custom domain name in the endpoint. Whenever you want to make use of this API, you need to make calls to the API. And for making calls, you need an endpoint. And this would be part of your endpoint. And that's why it needs to be unique. So add a few numbers in here to make it unique for yourself. Next thing you'd need to choose is the pricing tier. If you see a free pricing tier in there, go ahead and choose that. I have standard SO, so I'll choose standard SO. And I would check this checkbox. As you would expect with any solution which is related to artificial intelligence, it is very, very important to make responsible use of artificial intelligence. There is a lot of documentation about responsible AI in here. We'll discuss a few things about responsible AI a little later in the course as well. What I'll do for now is go ahead and say review and create. Azure is running the final validation right now. Once the final validation is done, we can go ahead and create our cognitive service. Cool, the validation is passed and now I can go ahead and say create. As you can see, it's initializing the deployment in here. The creation of the cognitive service would take a little while. What I would recommend you to do is to take a break and I'll see you in the next step. Welcome back. In last step, we kickstarted the deployment of cognitive service and our deployment is now complete. It took about a couple of minutes and after that I was able to see this page where it says go to resource. What I would do is to click go to resource in here. And this would take you to the cognitive service quick start page. The other way to reach this would be to search for cognitive services. So you can search for cognitive services. And over here, if you go to all cognitive services, you'd be able to see this in here. You'll also be able to see this if you scroll down on the left-hand side menu. And if you'd go for cognitive services, multi-service account. That's what we have created, multi-service account, because we would want to be able to play with multiple of these APIs. We created a multi-service account. You can also reach here by going to multi-service account and clicking this. Cognitive service in 28 minutes. And over here, you have a lot of documentation about the different services and the different APIs that you can make use as part of the cognitive services. The one which you'd want to play with is the computer vision API. We would want to analyze images. Now, how do we call the API with an image? What do we need to be able to call this service with an image? We would need an endpoint. Once you create a cognitive services multi-service account, you can go to keys and endpoint and get the details of the endpoint and the keys. The endpoint is where you can access the service. The key is like a password. As it says in here, these keys are used to access your cognitive service API. Do not share your keys. Store them securely. If you want, you can also regenerate the keys. If you think your key is compromised, you can come over here and regenerate the keys as well. To make an API call, either of these keys is sufficient. So just one key is sufficient to make an API call. Now, what we want to do is to make use of this endpoint and make calls to it. How can we do that? Let's go back to the documentation that we looked at earlier. This is the documentation page for all cognitive services. Over here, we are interested in the vision API, the computer vision API, and that's why we search for vision. And we chose a specific version of it. We chose the 3.1 version of it. It's one of the latest versions that is present right now. You can also use a later version of computer vision API if you see one of those in there. And over here, what we want to do is to make a call. We want to make a call to the analyze image operation of the computer vision API. So let's go ahead and choose the specific region. Which region should you choose in here? I would recommend you to choose the region that you have created this service in. If you go to the overview in here, you can see the specific region in which you have created your service. For me, it's West US. So you can go here and see West US. Where is West US in here? That's the first one. So what I would do is do a right click and I'll say open link in new tab. So I'll open up that in the new tab. And from here, you can invoke the analyze image operation. The first thing that we would need to configure in here is the endpoint. So what I would want to do is to use the endpoint which was created for us. That's why I would choose resource name.cognitiveservices.azure.com. And over here, I would want to give my specific resource name. So where do we have the resource name? We can go back to keys and endpoints. And you can pick up the name. So you can actually just pick up the name here. Cognitive service in 28 minutes. Make sure that you are getting this right. So cognitive service in 28 minutes without any spaces. This is the endpoint. And what do we need to be able to call this endpoint? We need the keys. So what I would do is actually copy this and have them in a text file so that we can reuse them a little later as well. So this is the resource name. The next thing I would need is the key. So this is the key which we would need. I've copied it from here and I've pasted it in here. So I'll use this key. If you scroll down a little bit in the computer, if you scroll down a little bit over here, you'll be able to see a place where you can enter the key. So this is where you can enter your key. So these are the two things that you would need to be able to call any cognitive service API. You need the endpoint, part of which is the resource name, and you would need a key. If you scroll down, you can see a request body. You need to send a path to a specific image you'd want to analyze. I will leave the default image in here and I'll go ahead and say send. This would give an error. You can see that there is an error coming back. It says image URL is not accessible. The test image is not really present. Earlier, we looked at this demo page where we played with some of the computer vision APIs. On this page, what I've done is I've picked up a few paths to the images. So Satya Nadella's image, you can say try another image and pick up the path to Statue of Liberty, for example. You can do a right click and copy image address. And what I also have picked up is the optical character recognition thing. So I've picked up this 42 Street. I've copied the image address for this and also the image address for one of these images. I picked up this image with water in the background. What I've created is a list of images with the path to them in here. So this is the complete path I've picked up from the web page. You can actually use any image of your choice. If it's available on the internet, you can use that to do the analysis. What I'll do now is I'll pick up one of these. So the image of set of buildings with water. This is the one which I'm making use of. I can do a right click copy image address and that's what we have in here. What I'll do is I'll pick this up and I would want to perform the operation on this. So let's go in here and say URL is this. So it's URL in double quotes, the path to the image in double quotes, and you can go in here and say send. And you would get back a few details. So you can see that it's returning a set of categories, building, outdoor, and it also is returning back metadata about this image. It's saying the height of the image is 360. The width is 510 pixels and the format of the image is JPEG. If you want, you can also go in and request for a few more details. So you can say in addition to the categories, let's say I would want to find out if the image is adult. So I can say comma adult. I can put comma in there. Let's go and fire a request now. I'll say send. And you'd see that the response contains if the image is an adult image, is adult content, is racy content, is gory content. As you can see, visual features is a comma separated list. So we have categories and adult in here right now. To this, I can add a few more. So if I go in to the start, so if I come out and click it, it would show a pop-up. So you need to come out of this and click again. Then it would show a kind of a pop-up where you can see the different things that you can add. For example, let's say I would want to add tags, and let's say I would want to find out image type and description. So description, image type, and tags. So description, image type, and tags. So let's add them in. So we have 5 in total right now. And let's go in and click send. So in addition to categories, adult, we also see image type. Is it a clip art? No. Is it line drawing? No. What are the tags? Water, sky, lake. Each of these is associated with a confidence level as well. And what are the other things that you can see in here? You can also see a description and you can see a text description of the image. A city skyline with water. In addition to analyze image, you can also play with some of the other operations which are present in here. Let's say I would want to get only the description of a specific image. What I can do is I can go to describe image, and over here I can do the same thing. So what I would do here, is go in here and pick up the specific region of yours. Mine is West US, so right click, open in new tab. So this is where I can make a call to the describe image operation. I would do the same things that we did earlier. So cognitiveservices.azure.com is what I picked. And I would need to provide this wildcard segment resource. And I would provide the resource name, cognitive service in 28 minutes. And I would use the key. This is the key I would want to put in here. And I would use one of the images, the same images with a set of buildings on water. So let's go in here and put that image in here. And let's do send. And you should see the response coming back just with the description. So it's providing a caption. So the describe image provides you just a specific caption. So the describe image generates a description of an image. If you only want the description of an image, you can go for describe image. If you want to detect objects, then you can go to detect objects. I can go into detect objects, and let's say I would want to go to West US and go in to the top, and let's pick up cognitiveservices.azure.com, and let's paste in this in resource name. Let's paste in the key. This time, what we would do is to pick up the image of Satya Nadella. So image for Satya Nadella, the way we picked it up is from the AI demos. You can go in here, say try another image, and yeah, I'm picking up the Satya Nadella's image from here and saying copy image address, and you can use that as the image where you'd want to do object detection, and let's say send. And what do you see? Yep, you can see a rectangle coming back. You can see the x coordinates, y coordinates, starting coordinates, and you can also see the width and the height of the object. And it's saying the object is a person, and the confidence level is almost 90%. And it's also returning metadata about the specific image. We played with the analyze the image, which gets a lot of details. The other operations which are present in here are describe image, detect objects, get area of interest. You can use get area of interest to get a specific area of interest in that specific image. You can use get thumbnail to generate a thumbnail for a specific image. If you want to get celebrities and landmarks from an image, you can make use of the domain specific content services. If you want to get the tags associated with the image, you can also make use of the tag image operations. In next step, we'll also play with the OCR operations which are present in here. There are a couple of optical character recognition operations in here, OCR and read. Let's look at them in the next step. In this step, we played around with the computer vision API. We looked at several operations related to computer vision API. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this quick step, let's look at the OCR operations that are part of the computer vision API. Optical character recognition. This is used to identify text from an image. And the interesting thing is that there are two OCR operations which are present as part of computer vision API. One is called OCR, the other one is called read. You can see them over here as well. You have OCR and you have read. These are the two OCR related operations that are part of the computer vision API. OCR is used to perform simple OCR. If you have a simple image like this and you'd want to detect image and you'd want to detect text in such an image, you can make use of OCR. However, if you want to do complex OCR, if you have a complex document, or if you have an image with a lot of text, or if you have a multi-page document, or if you have a document with multiple languages present, in those kind of situations, you can make use of the read operation. The OCR operation immediately returns back with the result because there is just small amount of text present. It's a synchronous operation. You call it, you get the response back. However, the read is an asynchronous operation. You need to make an additional call to get the result. When you make the initial call, you'd get a response saying, okay, we are processing it. And later, once the processing is complete, you can make a call to get the results. So if you have complex OCR to perform, you can go for read. If you have simple OCR, you can do it using OCR. Whenever you do OCR or read, you get a list of words as the result back. In the case of simple OCR, you get the lines and the words. In the case of read, there might be multiple pages. So you would get pages, lines, and words. And you'll also get the bounding box coordinates. So for each of the words, where does it start and where does it end? So you get the bounding box coordinates for them as well. In this step, we understood the different OCR operations that are part of the computer vision API. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. Starting this step, let's look at the Face API. We looked at the computer vision API until now. Let's switch our attention to Face API now. Face API is used for advanced face detection. You'd want to find out age of a person, or you'd want to find the emotion of a person in a specific picture, or you'd want to find out if a person is wearing glasses. Does he have hair? What kind of hair he has? What kind of makeup is the person in an image wearing? You have a list of images and you'd want to find similar faces. You want to match a face with a specific group and identify which picture in the group matches a specific face. These are all the operations that Face API can do for you. Let's see a quick demo. So if you do a Google for Azure Face API, you should be landing up on this page where if you scroll down, you can see demo of what we are talking about. So the first example is about face verification. So you have two images and you want to be sure that the person in the two images is the same. Over here, you can see that the verification result is that two faces belong to the same person and the confidence is 0.83. So almost 80% confident that these two people are the same. There are a lot of complexities associated with faces. A person might be wearing glasses. The lighting might be different. The angle in which a picture is taken might be different. So the confidence here is about 83%, which is good enough, but not perfect. Let's pick up a couple more images. So you can pick up an image here and you can see that the confidence for this specific image is about 93%. So the API is 93% confident that these two images have the same person. You can look at a couple of other examples in here as well. The confidence here is 91%. And over here, again, it's 91%. And let's see this one. Again, it's 91%. So that's face verification. Face verification is just one of the operations that is provided by the Face API. As we discussed earlier, face identification is complex. And that's the reason why you'd want to put additional effort to improve the accuracy of face identification. How can you do that? Number one is to improve the quality of the images. Have images with higher face image quality. So have frontal pictures which are really clear and the face size is 200 by 200 pixels or larger. Also have a variety of images. Don't just have one image per person. Have multiple images for each person. Make sure that these are from different angles and in a variety of lighting setups. The more images you provide, the more the Face API is confident about detecting a specific person. One of the operations that Face API allows you to do is to match a face with a group. And in those kind of situations, you need to create a group of faces. How do you do that? That's where you create a face list. Face list is a list of up to 1,000 faces. With this Face API, you can provide a face and you can try to match it against a face list, which can contain up to 1,000 faces. If you want to match against more number of faces, for example, I would want to match with a group of 1 million faces. In those kind of situations, I can go for large face list. So these are a couple of concepts which are part of the Face API, where you can create a group of images. If you have up to 1,000 faces, then you can go with face list. If you have up to 1 million faces, you can go with large face list. In addition to this, we also talked about the fact that to be able to identify a person, you need to have multiple face images. And that's where the concepts of person group and large person group become important. If you have up to 1,000 persons, you can create a person group. The person group can contain a number of persons and each person can have multiple face images. If you have more number of persons, you can make use of a large person group. A large person group supports up to 1 million persons. So you can store faces for up to 1 million persons using large person group. Now that we understood some of the important concepts related to the Face API, let's explore some of the operations that are exposed. As far as the exam is concerned, having a high-level overview of the operations is more than sufficient. So the first one is detect. Detect is used to detect human faces. You want to identify box coordinates of a specific face in a specific image. operation provides you with options to request for age, gender, head pose, smile. Does it have facial hair, glasses, emotion, hair, makeup, and a lot of other details. You can have up to 100 faces in a specific image. If you go to the Cognitive Services API's homepage and you search for face, you'd see face version v1.0, and this is the face API, and you'd see that there are a number of operations which are supported by the face API, and one of the most important operations is detect. And over here, if you select detect and you go to West US and you can scroll down, let's do the usual thing, resource name.cognitiveservices.azure. Let's pick up cognitive service in 28 minutes. That's the resource name. And let's take the defaults for all the query parameters for now. And let's put the subscription key. So this is our subscription key. I'll put it in here. And let's put the URL for the image. For this one, I would want an image with the face. I'm picking up the one with Satya Nadella on it. And let's go and put Satya Nadella's image in here. Let's do send. Response is okay. That looks cool. And you can see that the face ID is identified. So it's providing an ID back. So the face is now associated with a specific ID, which is the face ID. And it also is providing a rectangle back. So it's saying this is where the face is inside the image. Now you might want to get a few more details. How can I get few more details about the face? We can go and ask for face attributes. What are the different values that can be present in a face attribute? If you scroll up, you can see some of the attributes that you can request for. You can say age, gender, head pose, smile, facial, hair, glasses, and a lot of other things. What I would do is to ask for age and gender. So I'll say age, gender. So I'll scroll down again, and in face attributes, I would put age, gender. Let's remove the space in between, and let's fire the request again. What do we get? I'm getting an error saying head force. I'm getting an error saying these are not supported by detection 03. What does that mean? Okay, you can see that there is a detection model which is present in here, which is detection 03. And if you look at the documentation, it would say detection 03. This is a recent one which only supports a couple of face attributes only. And the default one which is detected, the default one which is recommended usually for face detect is detection 01. You don't really need to remember all these details. I'm just showing a demo of how to use the API. As far as the exam is concerned, they would not definitely go into this kind of a depth. So I'll go ahead and choose detection 01, and let's now try and fire it in. So there you go. You can see now a face rectangle is sent back as well as face attributes. It's able to identify that the gender of the person in the image is male. The guess of the age is around 46. I'm not sure when that specific image was taken. And let's see the current age of Satya Nadella. I guess he looks younger than his age. The Microsoft model is predicting that his age is 46. Until now, we looked at the most basic and the most important operation which is present in Face API, which is detect. There are a few other operations that are present in Face API as well. Find similar. You want to find similar faces. You have a group of images, and from the group of images, you would want to find images which are similar to a specific image. For example, find images of this specific person. That's when you would go for find similar. You have two important inputs. One is the image to match for. You can provide a face ID of the image that you want to match for, and you can provide a face list or a large face list. Earlier, we talked about the fact that you can create a group of faces by creating a face list or a large face list. Once you create a face list or a large face list, you get an ID for that specific thing back. So over here in Find Similar, what you are doing is to match one image against a group of images. So find images of this specific person. And the output of this operation is array of most similar faces. From this group of images, which of the images match the current face? The next operation is group. You have a number of images with faces, and you want to divide them into groups based on face similarity. That's what you can do with the group operation. The input to this is a list of face IDs. Once you have a list of faces, the output is matching groups of faces. So you can think of it as multiple arrays where each array contains a number of matching faces. There is also an identify operation which helps you to do one-to-many identification. You have a group of images. From those images, you would want to find the closest match for a specific person's face. The first input is the image to match for. The second input is the images to match against. You have a group of images, face list or a large face list. The output of the identify operation is the person candidates for that face. These are ranked by confidence. The highest confidence person is listed first. There is also an verify operation which allows you to do two things. Do two faces belong to the same person? You can pass in an input with two face IDs. You pass in two faces and you want to find out if those two faces belong to the same person. That's what we looked at earlier in the demo. That's what we were making use of in here, face verification. The other thing you might also want to do is to identify if a face belongs to a specific person. You might have a number of faces that are related to a specific person that are stored, and you would want to check if this face belongs to a specific person. Those are the two things that you can do using a verify operation. As far as the exam is concerned, it is very, very important to have a good idea of each of these operations. So if you have a category of images and you would want to divide them into groups, you would make use of the group operation. If you have a set of distinct images and you'd want to identify a specific person, you can use the identify operation. If you want to match two images and find out if they belong to the same person, or if you want to take a set of images of a specific person and use them to find if a face belongs to the same person, you'd make use of the verify operation. In this step, we looked at Face API and the important operations that are part of Face API. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's play with the Form Recognizer API. Form Recognizer is to get intelligence from scanned forms. You want to extract information from forms and images. Let's quickly look at a demo for it. So this is the home page for Azure Form Recognizer, the AI-powered document extraction service that understands your forms. So if you scroll down, you can see a few examples in here. You can see that the form, which might be a PDF or an image, is scanned, and you get all the information from it. You get key value pairs. So you can get who the bill to is, what is the phone number, what is the invoice number, and all such details. And if you scroll down, you can also see the information in tables. You can see the item numbers, you can see the description for each of the items, the quantity. So you can see that all the text from the image is scanned and made available as a JSON. So you can go in and get the entire JSON over here. Once you go to JSON, you should see a JSON like this with a lot of details about the specific form. The Form API, the Form Recognizer API supports a number of operations. These operations can be performed over PDFs or images as well. You can analyze business cards, you can analyze ID document, you can analyze invoices, you can analyze receipts, or you can also analyze your own custom forms. You can design and extract key value pairs, tables, and semantic values from your custom documents. These documents can be PDF or image. If you want to scan a receipt or an invoice or an ID document, the API you'd go for is Form Recognizer API. I'll see you in the next step. Welcome back. In this step, let's look at a few scenarios related to cognitive services related to vision. Recommend a service. Detect and identify people and emotions in images. Which service would you make use of? Face API. So if you want to identify people and you'd want to detect emotions, Face API is the recommended service. recommend a service. Extract visual features from image content. You would want to extract maybe description or tags from an image. Which one would you go for? Yep, it's easy. Computer vision API. Recommend service. Get intelligence from scanned forms. Whenever you have something like forms or receipts, you'd go for Form Recognizer API. When we talked about computer vision API, we talked about read and OCR operations. When do you use read operation to perform OCR in computer vision API? When you have text-heavy images or multi-page documents or documents with multiple languages, that's when you would go for read operation. How can you improve the accuracy of face identification? What can you do? Make sure that you have very clear images. Make sure that these are of the right size. Make sure that you have a variety of images from different angles and in variety of lighting setups. This would help the Face API to detect faces better. Let's look at a few scenarios related to Face API as well. For the next 4 scenarios, what we would do is we would try to identify the right Face API operation. You'd want to divide candidate faces into groups based on face similarity. So you want to find if all the faces belong to a specific group. The recommended operation would be group. You want to find the closest matches of specific query person face in a group. If I make it non-technical, you want to find the matches of a person in a set of images. What operation do you use? You'd want to use identify. You want to find out if 2 faces belong to the same person. This is verify operation. You want to find out if a face belongs to a specific person. Again, this is verify operation as well. In this step, we looked at a few scenarios related to vision services and Face API as well. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In the last few steps, we talked about cognitive services related to vision. We talked about computer vision API, Face API, and form processing related APIs. Let's now switch our attention towards natural language processing. Natural language processing is all about getting intelligence from conversation, speech, and written text in human languages. You might have unstructured text where you'd want to extract meaning from. That's where language services come into picture. One of the language services offered as part of cognitive services is text analytics. It is used to detect sentiment, key phrases, and named entities. Let's look at a demo for it. When you enter a sentence in here, text analytics gives you the sentiment and key phrases. So I'm picking up the default message which is present in here, and I'm clicking next step. And you can see that it shows sentiment. It says the sentiment is neutral. This is a statement saying Saturn is the 6th planet from the Sun and the 2nd largest in the solar system after Jupiter. It is a gas giant with average radius about 9 times that of Earth. This is just a statement, so there is no sentiment attached with it. It's neither negative, it's neither negative nor positive. It's neutral. You can also see that the key entities are identified. So the keywords in that statement are all identified as well. If you click next step, you can see that all these entities are linked. So if I click the link and open in a new tab, you'd see that it takes you to the Wikipedia pages. This is what is called entity linking. If you do next step, it will also bring you search results for those entities from Bing. The most important part of text analytics is the first step which is present in here, where we enter a message and we get sentiment and key phrases from the text. Let's say start over. And let's go in here and enter some text. I'll say, I hate this. And I'll say next step. You'd see that the sentiment is negative. It identifies that the sentiment is negative, and there is not a lot of text, so there are no keywords in here. So text analytics allow you to detect sentiment, key phrases, and named entities. Another language service is translator. You have text which you want to translate from one language to another. Translator service can do that for you. It can translate to from almost 90 languages. The next set of services are related to speech. whenever we talk about natural language processing, it's not just written text, it is also spoken text. The most important cognitive service related to speech is the speech service. It helps you to convert speech to text, text to speech. It can help you to translate speech from one language to another language. And you can also recognize a speaker based on the speech. These are all the capabilities which the speech service provides you with. One of the important things that you need to remember is if you want to translate speech from one language to another language, you need to make use of the speech service. However, if you want to translate text, written text from one language to another language, you need to make use of the translator API. The next set of services under natural language processing are to build conversations. You might want to build a chatbot. What are the things that you would make use of to build a chatbot? The first thing is Q&A maker. It provides the conversational question and answer layer. You might want to put a chatbot on your website where you type in a question and the chatbot looks up in a database and gets back with an answer. The backend question and answer layer for such bots can be built by using the Q&A maker. Another important component of building applications around conversations is LUIS, Language Understanding Intelligence Service. LUIS understands spoken commands. It also understands text commands. You can get information from users' natural language utterances. For example, turn lights off, turn lights on. These are all natural language utterances. LUIS will help you to understand them and convert them into actions. Good examples are book me a flight to Cairo or order me 2 pizzas. LUIS will be able to understand them and it would be able to convert them into intent, into actions. Let's look at a quick demo for LUIS as well. Over here you have a house and you can control the lighting of the house by sending commands to LUIS. So you can say, I would want to go to energy saver mode. And you can see that most of the lights in the house, actually all the lights in the house are switched off. You can say I'm concentrating on my work and that specific work area is now lit. You can also type in commands. Turn lights off. All lights are now off. Or you can say turn all lights on and say apply. And it works. You can also use speech. You can speak something, you can speak the command, and LUIS would execute it for you. LUIS is all about understanding spoken and text commands. In this step, we looked at the most important category of cognitive services under natural language processing. We talked about language services, text analytics and translator. We talked about speech service. And we talked about services which help you to build conversations, Q&A maker and LUIS. Let's explore these services further in the next few steps. I will see you in the next step. Welcome back. Starting this step, let's explore the Text Analytics API. Text Analytics API is part of Natural Language Processing or NLP. It helps you to analyze text and get a lot of details from it. Let's look at a demo for Text Analytics. Text Analytics is a text mining AI service that uncovers insights such as sentiment analysis, entities, relations, and key phrases in unstructured text. What are these? Let's scroll down and see a demo for it. So there is a paragraph which is present in here, and Text Analytics can analyze that and give you all the key things from that piece of text. It gives you the language of the text. It's English, and it says the confidence is 100%. It can identify the key phrases from this piece of text. You can see all the key phrases, dinner party, great menu, chief cook, all of them are identified and listed in here. And you can also see that the sentiment is identified, whether it's positive, whether it's negative, whether it's neutral. Most of this paragraph has positive sentiment. If you click JSON, you can see the exact JSON the service returns back. It returns the detected language as English. It returns the ISO name of the detected language, which is EN. It returns a confidence score, and it returns the key phrases. You can also see that it returns sentiment. It returns the total sentiment, and it also returns the sentiment for different sentences. The first sentence is 99% positive. Next thing is the sentiment for the second sentence, so on and so forth. You can also see that it is returning entities which are present in the document. You can see that it's identifying Contoso Steakhouse as a location. So these are entities. Entities are nothing but the locations or cities or people that are talked about in a specific paragraph. This phone number is an entity. The email address is an entity. So these are the different entities which are present, and these are all identified by the Text Analytics API. So you can scroll down this, you can scroll through this and look at all the different things which are identified in here. So Text Analytics API provides you with a lot of features. Sentiment analysis, whether the sentence is positive or negative. If you have a review posted on a website, you can use sentiment analysis to find out if the review is positive or negative. You can extract key phrases from a paragraph. You can detect the language. As part of the Text Analytics API, there are multiple operations. One is detect language. Obviously, it provides you with language name. It provides you with the ISO 6391 code of the language. It also provides you with a confidence score. If the Text Analytics API is unable to detect the language, it would return NaN. You can also identify entities containing personal information. We talked about the different entities which might be present in a paragraph. People, addresses, all these are entities. Some of these entities are personal information. Let's say there is a SSN present in the text. There are details of a bank account which are present in a paragraph. These are personal information. Entities containing personal information operation helps you to identify the personal information which is present in a piece of text. You can also identify the key phrases which are present in a piece of text. For example, you'd want to summarize a specific document. You can also identify the different entities which are present in a given piece of text. This is called named entity recognition. We saw that phone numbers, emails, persons, locations, they were all identified. So person, location, organization, quantity, date time, URL, phone number, IP addresses, these are all entities which can be recognized. You can also detect sentiment, detailed sentiment analysis. Whether it's positive or negative review, it would also give you the extent. Anything near to 0 is very negative. Anything near to 1 is very positive. If you go back to the documentation for cognitive services and you search for text analytics, text analytics, and you should see multiple versions of this API. I would pick up the 3.1 version of the Text Analytics API, and you can see that it's a suite of natural language processing services built with best-in-class Microsoft machine learning algorithms. It can be used to analyze unstructured text for sentiment analysis, key phrase extraction, and language detection. And you can see that there are a lot of different operations which are present in here. Let's pick up one of these and play with it as an example. Let's pick up key phrases. Let's pick up the region where we have created the cognitive service. Earlier we created a multi-purpose cognitive service, and this can also do text analytics. So let's click in. Which region did we create it in? My specific one was created in West US. So let's pick up West US from here. And let's go to the second one, which is star.cognitiveservices.azure.com. And let's enter this. The name of the cognitive services multi-service account. So this is the endpoint which we would want, and that's what we have configured in here. And I'll take the defaults for most of the things. We would need to put the key in. I already have the key in here. I'll paste it in. If you want to get the key, you can go to keys and endpoints, and you can pick up one of the two keys which is present in here. And over here is where we would want to put in the text we would want to analyze. So let's say sun is a star, and let's say the language is English. So I'm putting in EN, the ISO code for it in here. And let's go ahead and say send. You can see that it is identifying the key phrases in the sentence I have typed in. It's a very, very simple sentence I've typed in, and it's identifying the key phrases in there. You can do a similar thing with any of the other operations as well. Let's pick up sentiment, for example. Let's go over to West US and let's pick up star.cognitiveservices.azure.com. Let's paste the name in here. Let's put a key value, subscription key value in here as well. And over here, I'll put the text. Sun is a star. And you want to identify the language, and you'd want to put EN as the language, English. And I would say send. And response status is 200. And you can see that it's saying it's neutral sentiment. So it's able to identify the fact that the total sentiment is neutral. There is one sentence. Even that sentence has a neutral sentiment. Let's change this and let's say, I love to cook. And I would say send. And you can see that this is returning positive sentiment. Let's say I add in one more sentence. I'll say I love to cook. And I would say but I hate doing dishes. Let's go ahead and say send. Now you can see that the sentiment is returned as mixed because there are two sentences. One is positive, the other one is negative, and the sentiment is now returned as mixed. However, if the two sentences were both positive, let's say I'm saying, and I love doing dishes. Let's say that's the thing which we are sending. What would you get back? So you can see that the overall sentiment is positive. Both the sentences are also returned back as positive. You can make a call to the endpoint with the right request and response format. You can look at the request URL. You can look at the details of the HTTP request that we are sending in. If we send similar kinds of requests from any of your applications, you can communicate with the cognitive services and perform whatever operations that you would want to perform. In this step, we looked at Text Analytics API. Text Analytics API can do sentiment analysis, key phrase extraction, language detection, detecting entities. So all these things can be done using the Text Analytics API. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. From Text Analytics, let's move towards Translator and Speech APIs. Translator Text API is used to do text-to-text translation. It supports translation for a huge number of languages, and you can also translate from one language to multiple two languages. For example, you can translate from English to French and German as well. So if you want to do text-to-text translation, you can go for the Translator Text API. However, if there is speech involved, then you would go for speech-related APIs. You have APIs called Speech-to-Text API, which provides real-time and batch transcription, where you can actually convert speech to text real-time, or you can have a batch of audio recordings and you can convert them to text as a batch. Doing speech to text is called transcription. Let's pick up the URL from here. And this is where you can write the speech to text API. I just speak in here. It's asking if I would want to allow it to use the microphone. I would say allow. And I would say whatever I'm speaking right now. Let's see what it would be recording. I'll say stop now. You can see that it's automatically recognizing whatever I'm speaking. This is speech to text, and this is real time. You can do the same thing by uploading a file. This is more of a batch, where you upload a set of files and you transcribe them. So this is speech to text API, which helps you to convert speech to text. This is also called speech recognition. The other API is text to speech. This is called speech synthesis. Let's look at a demo for text to speech as well. So text to speech is a speech service feature that converts text to lifelike speech. You can put whatever text you would want to put in here, and you can say play. I'm sure you've not heard it with the same quality as I was speaking, but you would have heard that this text is being converted into voice and played back. You can specify the language, you can choose from different voices, and you can also configure speaking style, speaking speed, and pitch. So if you want to convert text to speech, you can make use of the text to speech API. This is called speech synthesis. The other APIs involving speech are for translation. If you want to convert speech in one language to text in another language, you can make use of speech to text API. You can also translate speech in one language to speech in another language. This can be done by using the speech to speech API. Let's look at a demo for it as well. I can scroll down in here and I can choose the source language and the target language. I can say, let's say the target language is Telugu, which is my mother tongue. I'll try and speak a little bit. So I click speak and I'll say Ella in here. And I'm trying to speak something. Let's see if it's converting it into the target language. I think it's doing a pretty good job. I'll click stop now. It's actually doing a pretty good job of identifying my speech and converting it into Telugu text. Now it might be interesting to listen this in Telugu. మరియు నేను ఏదో మాట్లాడడానికి ప్రయత్నిస్తున్నాను. అది తెలుగు అనే టార్గెట్ లాంగ్వేజ్గా మారుస్తుందా లేదా అనేది చూద్దాం. ఇది చాలా మంచి పని చేస్తుందని నేను అనుకుంటున్నాను. ఇట్ డిడ్ అ pretty good job actually. So whatever I spoke in English was understood and converted to text in Telugu language. So this is speech to text translation. Speech in one language converted to text in another language. In this step, we explored some of the translator and speech APIs. I'm sure you're having a wonderful time and I'll see you in the next step. Welcome back. Starting this step, let's explore conversational AI, conversational artificial intelligence. Software that can carry a conversation like humans. Software that can talk to other humans like a human. Let's look at a demo for conversational AI. The demo which we are looking at is of Azure Health Bot. This service empowers healthcare organizations to build and deploy an AI-powered conversational healthcare experience at scale. This service actually combines a number of AI-related services that are provided by Azure. Let's quickly try a demo in here. You can say, try a demo of an example in user experience. Make sure that you're clicking this and not try for free. We are clicking try a demo of an example and user experience. Once you click that, you can type in your message in here. Let's say I have fever. So this is kind of a conversation I'm having. I'm saying I have a fever and it says the following symptom is registered and it's asking me what's your sex. Let's say I'm saying it's male and it's asking what's your age. Let's say I enter 40. Now it's asking me for more symptoms. Do you have any of these symptoms? Let's just pick up a couple of them. And you can continue having this conversation. So this is the kind of solutions that you can build with the conversational AI solutions. The typical use cases for conversational AI are customer support. Somebody is making use of your service and they have a problem. You can offer a customer support bot. Or you can have a bot to do reservations. I would want to book a table for dinner. Or you want to do automation. Earlier we looked at an example with Louise, where you give an order and based on it, lights in different parts of the house are switched on and off. All these use cases can be done using the conversational AI solutions which are provided by Azure. Some of the important services as part of conversational AI are Q&A Maker. Q&A Maker helps you to convert your FAQ into Q&A bot. You might have a number of documents with frequently asked questions. If you want to create a bot around them, if you want to translate them into a question and answer bot, in those kind of situations, you can make use of Q&A Maker. When you're using Q&A Maker, you need a knowledge base. In the Q&A Maker, you need to feed in the questions and answers. The Q&A Maker by itself cannot talk to a DB. You have to go in and feed the question and answers. These question answers can be in a website, in a document. You can feed from there into the knowledge base And you can use Q&A Maker to deliver the conversation service around the knowledge base. The other service is Azure Bot Service. You might want to build your own bots and you want to enable conversation over multiple different channels. Enable conversation by email. You would want to provide support on a Facebook page, or you'd want to use Microsoft Teams or Skype or Slack or Telegram to provide support. So these are all the channels on which you can build bots and you can integrate with the Q&A Maker. So you can provide your customer support on multiple channels if you can integrate Q&A Maker with Azure Bot Service. Typical architectures in conversational AI involve Q&A Maker service and exposing it to multiple channels using Azure Bot Service. In this step, we looked at how you can build conversational AI solutions in Azure. In the next step, let's look at a demo for conversational AI. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's build a conversational AI solution. We will start with building Q&A Maker. Let's build a simple Q&A Maker around questions that are typically asked around courses in 28 minutes. If you type in cognitive services, you would reach in here. So if you type in cognitive services in here, you can reach out to cognitive services. And to create a Q&A Maker, you need to go to Q&A Maker. And this is where you can go in and say, create Q&A Maker. Once you go in there, you can see that Q&A Maker is a cloud-based API service that lets you create a conversational question and answer layer over your existing data. You can extract questions and answers from your semi-structured content like FAQs, manuals, and documents. And you can use Q&A Maker to expose a conversational question and answer layer. So you can choose free subscription if you are in free subscription. Otherwise, you can choose the pay-as-you-go subscription. We will create a new resource group. So I'll call this Conversational AI RG. So all the things that are related to conversational AI, let's put it in this resource group. I'll choose the default region which is recommended, and I would choose the name of it as Courses QA Maker. And I'll choose the pricing tier as free. Let's scroll down, and the next thing that you need to choose is Azure Search Details for data. When you create a Q&A Maker resource, you host the data in your own Azure subscription. Take the default region which is suggested, and I'll choose the free option in here. So I'll say free F3 indexes. The Q&A Maker needs to be deployed somewhere. There is a database attached with it, and there would be some kind of a compute attached with it as well. That's what we are configuring in here. So you need to configure the compute for Q&A Maker as well. I'll take the defaults which are suggested in here, and I would say review and create. Let's go ahead and click create now. The creation of the Q&A Maker would take a little while. You can see that the deployment is now in progress. There are a lot of things that are being deployed. The deployment of the Q&A Maker would take a little while. I would recommend you to take a break, and I'll see you on the other side. Welcome back. The deployment of the Q&A Maker took a couple of minutes, and at the end of it, I see a message saying your deployment is complete. I would say go to resource, and over here in the quick start is the link to the Q&A Maker portal. So I'll click this link in here. It's in step 2. So I'll go ahead and click the Q&A Maker portal link in there. The Q&A Maker portal is where you can go in and create your knowledge base. You'd want to store a list of questions, answers, and you'd want to test the service. That's what the Q&A Maker.ai site enables you to do. So there are, as you can see in here, there are multiple steps. We have already created a Q&A service in Microsoft Azure. So that's done. What you would need to focus on now is step 2. Connect your Q&A service to your knowledge base. Before that, we will need to actually create a knowledge base. So let's shift our attention to step 2. Let's choose the subscription. You might have free subscription, choose free subscription, and you can choose the Q&A service name that we created earlier. I named it as Courses Q&A Maker. So let's pick that up, and it would bring up a set of languages. I would say I would want an English language bot. And next is the knowledge base. So I'll call this Courses knowledge base. The next thing that you would need to do is to import your question and answers. So you can extract question and answers pairs from online FAQ, product manuals, or other files. There are a wide variety of formats that are supported: PDF, doc, docx, XLSX. What we would do is we would skip this step. What we would do is we would manually add the question and answers. So I would skip this step and scroll down. And I would go ahead and say create the knowledge base. So let's click create the knowledge base. So as it says in here, hang tight, and we are now on the knowledge base configuration screen. This is where you can edit your knowledge base. This is where you can add question and answers to our knowledge base. Now let's add in a few questions. Let's start with the first one. What courses do you offer? And I'll paste in, and the answer I would say is DevOps and cloud. And I would want to add another question. What DevOps courses do you offer? Let's say I would enter Docker, Kubernetes, Terraform, and Azure DevOps. Let's add one more question saying what cloud courses do you offer? And I would say the answer is, let's say, certification and hands-on courses on AWS, Azure, and Google Cloud. I'll add a few questions so that we can have an interactive conversation. So let's add one more question. What Azure courses are offered? And let's just say it's AZ-900, DP-900, the course that we are doing right now, AI-900, and let's add in one more, which is AZ-400. Let's say these are all the questions I would want to have in my knowledge base. Once you add the questions, you can train the model. How can you train the model? It's by clicking Save and Train. And the training is now in progress. As it says in here, hang tight. This should take only a minute. So the training is now done. I can go ahead and do test. So I can go to test and I can now type in questions. So I'll say, what courses are offered? And you can see that it returns back DevOps and cloud. You can see that this question is a little bit different from what was configured in here. I just said, what courses do you offer in here? Here we are asking what courses are offered. This is a very simple example. Let's say, do you offer AZ-900? You can see that it's able to recognize and return back AZ-900, DP-900, AI-900, and AZ-900. It's saying, yes, it's offered. So even if the questions are a little different, the Q&A maker is able to recognize that and give you the right answer. If you see that Q&A maker is not giving the right answer for a specific question, you can also add alternative phrasing for each of these questions. You can go in for a specific question and say, I would want to add in alternate phrasing. Once you have played with it, once you are confident that everything is working fine, you can go ahead and publish your knowledge base as well. So let's go ahead and say publish. So what would happen when we publish our knowledge base is that a REST API is created. You can use this URL and you can send your question to it. So in the body of your request, you can send the question. There is also an authorization endpoint key you'd need to make use of. So if you make use of this authorization endpoint key and send a question in, it would respond back with an answer. If you know how to do a curl, you can also do a curl to it as well. So you can see that you can use this. You can replace your question in here with your question and do a curl request to that as well. So now the knowledge base is offered as a REST API. So the role of Q&A maker is to create a REST API around your knowledge base. Now the REST API is ready. What do you want to do? You want to offer this over multiple channels. And that's where bots come into picture. Let's see how to create a bot in the next step. Welcome back. In the last step, we made use of Q&A maker to offer a REST API around our knowledge base. In this step, let's create a bot. Over here, I can say go ahead and create a bot. So on the screen, if I click create a bot, it would take you to a new screen where you can start creating a web app bot. I'll call this bot courses Q&A. And I'll choose the defaults which are suggested for rest of the things. I'll choose the pricing tier as F0, and I would take the default for app name. You can see that there are two types of SDK languages that are supported, C# and Node.js. So you can build your web app bots in these two languages. I'll take the defaults for rest of the things and I'll say create. So the deployment is now in progress. Within a minute or so, I saw this screen saying deployment succeeded. If I actually hover over here, I can see deployment succeeded and I can say go to resource. You can also search for the name of the resource which we created. And it would be in the recent resources. You can pick it up from here as well. Over here, you can look at the details of the bot. If you want to test the bot enough, I can go to test in web chat. And over here, you can start typing your messages. What Azure courses are offered? And it returns back the response back. What's happening in here is the bot over the web is making a REST API call to the Q&A maker service, which is responding using the knowledge base. So, do you offer DP900? So a REST API call is going in the backend and it's responding back with this. The great thing about the bot service is that you can expose it on multiple different channels. So over here, if you go to channels, you can see that there are a lot of channels on which you can expose your bot on. You can expose it on Microsoft Teams channel. You can expose it on Alexa, Facebook, Skype for business. You can expose it on Slack or Telegram or Skype or Outlook. You can expose it on a number of channels. And after you play with it, let's go ahead and delete all the resources that we have created. So let's go to resource groups. And all the things that we have created in the course QA Maker resource group. So let's select that. And I would copy this resource group name and say delete resource group and paste the resource group name in here and say delete. The deletion of the resource group is in progress. In the last couple of steps, we saw a demo on Q&A Maker and the Azure bot service. Q&A Maker allows you to expose a REST API around your knowledge base, and Azure bot service would help you to connect it to multiple channels. Alexa, Office 365 email, Facebook, Microsoft Teams, Skype, Slack, Telegram. There are a number of channels which are enabled by Azure bot service. I'm sure you're having a wonderful time and I'll see you in the next step. Welcome back. In this step, let's understand another conversational AI service, which is LUIS, Language Understanding Intelligence Service. It helps you to understand spoken and text commands. It helps you to get information from users' natural language utterances. Book me a flight to Cairo. Order me 2 pizzas. When you say this in an application, the application needs to understand it and execute an action. The first step of understanding it can be made simple by using LUIS. What LUIS does is it converts the command into intent and entities. Let's look at a few demos. This is demo 1, which we already looked at. You have a house and you can send a few commands out. You can either type them in, choose one of these, or you can speak the commands in and the right action is performed. The next demo, the link to it is really big. That's why we embedded it as a link in here. So you can do a right click and copy link address. And you can go to that demo. As we have been talking until now, language understanding or LUIS is a service that allows users to interact with your applications, bots, and IoT devices by using natural language. So take this example, and let's say the command I'm sending in is turn the light on. The input to Luis is the command, turn the right light on. What Luis does is it converts the query or the command into intent and entities. So you can see that it's saying the intent is turn on and the entity is right light. And it's saying it's 90% confident. Let's say switch all lights to green. You can see that the intent is turn all on, and you can see that in the entities is the color green. So whatever query is sent, it is converted into intent and entities. And other programs can make use of the intent and entities and take appropriate action. For example, if I say switch floor lamp to green, you can see that the intent is to turn on, and it's saying there are two entities which are involved. One is the floor light and the other one is the color green. Let's look at another interesting demo for Luis. I'll pick up this demo 3. It's luis.ai. This is again a website which is maintained by Microsoft. And over here, you can scroll down and see language understanding in action. So if you say book me a flight to Cairo, what happens is the query is converted into a prediction. The prediction contains intent and entities. You can see that the top intent is book flight and the entities is location, Cairo. So we would want to book a flight to Cairo. If you do order me 2 pizzas, you can see that it's a food order. So the top intent is that it's a food order and it's really confident. It's 99.999% confident. So that's good. And you can see that the entities which are involved are number and food type. So the number is 2 and the food type is pizza. So as you can see in here, you can use Luis to convert queries into predictions. The prediction includes intents, entities, and the top intent. So Luis helps you to detect intents, food order or book flight, and entities, pizzas or book flight to Cairo. Because Luis can understand intent and entities, you can integrate it with Azure Bot Services for an end-to-end conversational solution as well. In this step, we talked about Luis. We saw a few demos on Luis. The most important thing to remember about Luis is that it helps you to convert a query or a command into intents and entities. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's look at a few scenarios related to natural language processing. We have looked at a number of services related to natural language processing. Let's look at a few scenarios related to them. You want to get intelligence from conversation, speech, or written text in human languages. That's where we go for natural language processing. Now, let's look at specific services. You want to detect sentiment, key phrases, and named entities from text. What service do you make use of? You can make use of the Text Analytics API. You want to detect key phrases from a document. What do you make use of? Again, it's Text Analytics API. Actually, this is kind of a repeat scenario. This is actually from text. This is from a specific document. Either of them can be done by using Text Analytics API. You want to do text-to-text translation. Important thing in here is it's text-to-text. When you want to do text-to-text translation, you can make use of the Translator Text API. So you can make use of the Translator service. Recommend a service for speech recognition. You want to convert speech to text. What can you do? You can make use of the Speech-to-Text API. Recommend service for speech synthesis. You want to convert text to speech. That's when you would go for text-to-speech API. The speech-to-text API, text-to-speech API are all categorized as speech services. Let's look at a few more scenarios. Translate speech in one language to text in another. Again, another speech service, which is speech-to-text. Now, we are shifting our attention to conversations. As you can see, under natural language processing, we have speech, text, and also conversations. So you are building software that can carry a conversation like humans. Which category of AI does it fit into? it fits into conversational AI. Let's now look at specific services. You want to convert your FAQ into a question and answer REST API. You want to build kind of a service around your FAQ. You can make use of the Q&A maker. You want to build a chatbot to answer questions from your knowledge base. You can make use of Azure bot service, and you can use Q&A maker service to expose the question and answers in your knowledge base. The next scenario is related to Q&A maker service. Can you directly connect Q&A maker service to a database or an external system? The answer is no. In the Q&A maker service, you can actually create question and answers directly in there, or you can go and import the question and answers into the Q&A maker service. In the next scenario, you have to recommend a service. You want to understand spoken and text commands, and you want to get intent and entities. Which one do you make use of? Yep, it's Louis. Language understanding, intelligent service. Next scenario, you want to perform sentiment analysis on reviews posted on a website. There's a website, there are reviews posted on there, and you'd want to find out if they're positive or negative. That's what is sentiment analysis. You can make use of the text analytics API. In this step, we looked at a number of scenarios related to natural language processing. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. From conversational services, let's move to decision services. One of the most important decisions that you typically need to make is to find if something is going wrong. You want to find anomalies, and anomaly detector service helps you to do that. It helps you to identify unusual actions, behavior, or errors. And it can be done in batch or real time. A few use cases where anomaly detector is very useful include finding fraud, finding unusual transactions on a credit card, and finding defective parts. Let's look at a demo for anomaly detector. And over here, you can see that the anomaly detector can be used to detect anomalies automatically in time series data. And if you scroll down, you can see the specific request and response. You can pass the entire series of data. So this is a time series of data. So series of values 826, 799, 890 that we are sending in. And the anomaly detector service can identify if there is an anomaly in there. It's saying is anomaly is false. There is no anomaly. Is there a positive anomaly? Is the value increasing drastically or is the value decreasing drastically? The answer is no. So you can send time series data in, and the anomaly service can find out if there are any unexpected changes in the time series data. Another decision making service is content moderator service. A lot of the websites have user generated content. Users might be uploading videos, images, they might be posting on a forum. You'd want to moderate content, and that's where you can make use of the content moderator service. It allows you to do image, text, and video moderation. You can look for private information of an individual, and you can also create a custom list of text you'd want to detect and moderate. The input to the content moderator system is an image or text or a video, and it would return the content assessment results. Based on the content assessment results, you can take appropriate action. If you want to take down a video, or if you want to remove a specific image, or if you want to prevent a review from getting published, you can take those decisions in your applications. A few example APIs which can do content moderation include image evaluate. This returns the probability of an image having racy or adult content, and text screen. It can scan for profanity in 100+ languages. In this step, we looked at decision services. The important thing that you need to remember is if you want to find out fraud or unusual transactions, or if you want to find defective parts, if you want to find anomalies, in those kind of situations, you can go for anomaly detector. If you want to moderate content, whether it's image, text, or video, in those kind of situations, you can go for content moderator services. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's look at a few scenarios related to decision services. You want to detect unusual actions, behavior, or errors. You want to find out unusual transactions on a credit card, or you want to detect fraud. Which is the recommended service? The recommended service obviously is anomaly detector. You want to detect unwanted content. You might have a website where people are uploading images or videos, and you'd want to ensure that there is no unwanted content in there. That's where you'd go for content moderator. You want to perform profanity scan on reviews posted on a website. So this is text. Content moderator can do this as well. Access multiple Azure Cognitive Services with a single key and endpoint. How can you do that? That's when you'd create a Cognitive Services multi-service account. For all the services we have talked about until now, you can go in and create an account for that specific service alone. So if you want to make use of Text Analytics API, or if you want to make use of the Vision API, you can create an account with support for just that. However, if you create Cognitive Services multi-service account, you can access most of the cognitive services with just a single key and endpoint. And that's what we have been doing all through this course. What do you need to invoke a Cognitive Service API? The first thing you would need is an endpoint, which is basically the HTTP address at which your service is hosted. And you would need a key, which is a secret value used by your client applications to authenticate themselves. In this step, we looked at some of the scenarios related to decision services. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In the last few steps, we played around with cognitive services. We played with decision cognitive services, we played with language-related cognitive services, we played with speech-related cognitive services, and vision-related cognitive services. And to play with most of them, we made use of the Cognitive Services multi-service account. For creating the Q&A maker and chatbot, we created unique services for themselves. But for most of the other things, we made use of the Cognitive Services multi-service account. An important thing that you need to remember is that, let's say I would want to use only Face API. I don't want to use any of the other services. In those kind of situations, I can go and create a Face API service alone. So I can go to Face API, I can say create, and I can create a resource specifically focused on Face API. However, what we have done during the course is to make use of the multi-service account because this can provide multiple cognitive services capabilities. And it provides multiple cognitive service capabilities with single key and endpoint. You can use the same endpoint and access multiple different cognitive services. The time has come for us to delete the cognitive services that we have created. I can go in here and delete this cognitive service, but a better approach would be to delete the resource groups. So I'll go to resource groups and I would go into the cognitive services resource group that we have in here, and I'll say delete resource group and delete this specific resource group. So all the cognitive services that we have created until now will be deleted. One of the most important things that you need to understand about cognitive services is that we are making use of pre-built models. These models are already built by Azure and we are making use of them. The Azure machine learning team has invested a lot of time to train these models, the speech models, the vision models, the text models. All of these are trained and created, and we made use of those models through these services. However, the interesting thing will be to build your own custom models. How do you do that? That's what we will be exploring in the subsequent sections. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In the last section, we played with cognitive services. Cognitive services provides you with pre-built ML models. What if pre-built ML models are not sufficient for you? You want to build your own ML models. Azure provides you with a number of services that help you to build your own machine learning models. In this section, we'll be exploring a couple of them. One is custom vision, and the other one is Azure Machine Learning. In this step, let's get started with custom vision. Custom vision helps you to create custom models using your own images. If you'd want to get intelligence from your images, you can make use of the Computer Vision API as well. Let's say the details which are provided by Computer Vision API are not sufficient for your specific use case. You want to be able to identify specific machine parts, or you'd want to be able to identify specific type of objects in your images. In those kind of scenarios, you can create your own custom models. That's where you can make use of the Custom Vision API. You can create your own images, identify objects in them or tag them, and train the model. And later, you can use the same model to do the predictions. There are two types of projects that you can create with custom vision. One is classification projects. In classification projects, the input is an image. The output is a set of labels. There are two types of classification projects, multi-label and multi-class. In multi-label projects, you would want to identify multiple tags per image. In multi-class projects, you want to identify single tag per image. The other type of project which is present in custom vision is object detection. The input for object detection is again an image. The output is coordinates of a specific object in this specific image. The goal of classification is to be able to identify tags for an image. The goal of object detection is to detect specific objects in your image. Let's get started with a demo for custom vision. Again, this is an optional demo. Watching it should be more than sufficient. I would want to create a custom vision service. So I'll say custom vision in here, and you'd be able to pick up custom vision from here. And I would say create custom vision. I'll take the default subscription which is suggested. I'll create a new resource group. I'll call this custom vision RG and say OK. And I'll call this custom vision in 28 min. This should be unique. So I'm adding in 28 min to make it unique. You can also add a few things at the suffix to make it unique. I'll choose the default suggested location for training location. And for training pricing tier, I would choose free. If you scroll up, you can actually see that you have options to just create a custom vision service for training, or just create one for prediction, or you can create one for both. What we'll do is we will use the same service for both training and prediction. Training is the process where we create the model. Prediction is where we use the model and try to predict what's in the image. During training, you'd provide a number of images and you provide input saying, okay, this is where the object is present. These are the tags that are associated with this specific image. And during prediction, you would use the model to do predictions. The image is given as an input and the model would try and predict what's in that specific image. So let's leave it at both, and let's go ahead and say the prediction and let's choose the prediction pricing tier as free as well. So let's go ahead and say review and create, and go ahead and choose create. So the deployment is being submitted. The deployment would take a little while. It's in progress right now. It took a couple of minutes, and at the end of it, I see a message saying deployment is complete. Let's now go to the resource. So let's say I would go to the resource. And let's go to the custom vision portal. So under this step 2, you'd see a custom vision portal in here. Let's go and click that and take that link. So this is where we can do the training and prediction and everything. So let's go ahead and say sign in. I would recommend you to read through the agreements and agree to them. And we are right now in the custom vision dashboard. This is where you can create your custom vision projects. So let's go ahead and say create new project. The project I would want to do is to identify apples in an image. So I'll call this apple identification project. And over here, you would see a few important choices. The first choice that you would need to make is what type of prediction you are going to do. Are you going to do a classification or an object detection? Classification gives tags to the entire image. Object detection, the goal is to locate content within a specific image. If you choose classification project, you would have options to use two types of classification. One is multi-label and the other one is multi-class. In multi-label, you can associate multiple tags per image. In multi-class, you'll only be able to assign one tag per image. In addition to choosing the classification type, you can also choose the specific domain. If you know that the project you are going to do is about retail products, or is about landmarks, or about some food related things. In those kind of situations, you can choose those specific domains. What we'll do now is we will create an object detection project. We would want to identify apples in a specific image. We would want to identify where the apples are. And that's why we would go for object detection. Even with object detection, you can choose the domain. Which domain do you want to use? So the recommendation is to pick the domain closest to your scenario. If you are designing a project with logos, or if you are designing a project where you are putting a number of products on shelves, then you can make use of these two domains. If you want to use the models on iOS, Android, or other lightweight platforms, you can also try and create compact models. What I would do is I would choose the default domain and I would say create project. Once the project is created, you would be taken to the workspace of the project. This is where you can add images and you can also tag them. The first thing that we need to do is to add images. So let's go ahead and say add images. I've downloaded a few open domain images containing apples. We will be using them for the training and prediction. One important thing is for the training, you would need at least 15 such images. I would select all the images except for the last one. The last one we will use for prediction. So I'll select all the remaining one except for the last one and say upload. And I'll say upload 16 files. Cool. The images are now uploaded and you would see that all these are now untagged. If you go to tagged, you would see that there are no images under tagged. All the images are untagged because we did not identify the apples that are present in there. What we'll do is we'll go ahead and identify apples in each of these images. So all that you need to do is to select a specific image and then you can drag and drop a small rectangle around it. So make sure that you exactly identify the object. If you can also go and change the region. Once you selected the region, you can add a tag saying this is apple. So the apple in this image is present at this specific location. In the same image, you can actually identify multiple objects. For now, let's keep it simple and have just one object per image. I would do next. Over here, it brings up the next image and I would identify the apple in the next image as well. So this is the apple in the next image and I would choose apple as the tag in here as well. Just like this, I can go ahead and tag all the other images. So let's quickly tag them. So I would tag all the apples in the rest of the images. To be able to use the custom vision API, you need to have at least 15 tags for a specific object. So if you want to be able to identify apple, you need to have 15 images that contain apples and 15 images where you have already identified apples in them. And that's the reason why we uploaded significant number of images. So let's go ahead and let's quickly identify the apples in all the images. What we are doing in here is creating a data set. We are creating an image and we are tagging the objects. This is a little boring exercise to do, to be identifying objects from images. Typically, the creation of the data set is one of the most difficult parts of machine learning. Finding the right data to create your model based on and making sure that the data is good, that's a very, very tough part of machine learning. I guess I'm almost at the end. There should be just a few more apples that I would need to identify. Let's go ahead and make sure that we do a good job of identifying them. And click next again. Let's tag apple over here as well and say next. Okay, I'm at the final image and I've tagged all the apples in the images. And now I can say close over here. And once we complete the exercise of tagging all the images, you'd see that when you go to untagged, there are no images. And when you go to tagged, you'd see that there is one tag apple and you can see all the images under apple when you click the apple tag. So that's good. We have the data set ready. This is all the data that we want to use for training. So let's get started with creating a model. How do you create a model? You use training to create a model. So let's go ahead and do training. So I'll say train. There are two types of training, quick training and advanced training. If you do advanced training, you'll get really, really good results. But for the purpose of this course, quick training is more than sufficient. So what I would do is go ahead and do quick training. The training would take a lot of time. what I would recommend you to do is to take a break. Welcome back. In the last step, we kicked off the training. The training took about 20 minutes to complete. At the end of it, you would see something like this. Ideally, you need to have hundreds of images, identify multiple tags, not just apples, maybe multiple fruits. And then you can use the model to identify where different fruits are present in a specific image. Once the training is complete, we have the model ready. And we can use the model to generate predictions. The easiest way to do predictions is to go to quick test. Let's go to quick test and let's do a browse local files, and let's use an image which is not used for training. And let's see if it's able to identify the apple in here. You can see that the apple object is identified and it says it's 99.9% confident. So that's pretty cool, right? So we are able to identify apples in an image. So the most important things that you need to remember about custom vision are, if you want to train using your own images and you want to create custom models, that's where you go for custom vision. Training is the process where you create the model. You give a number of input images, you tag, you identify objects, and once the model is created, you can use the model to do predictions. There are two types of predictions that you can do with custom vision. One is classification, the other one is object detection. Object detection identifies objects in an image. It returns the coordinates of objects in an image. When you're doing classification, you'd want to predict tags or labels for an image. When you're using multi-label classification, you want to predict multiple tags per image. When you are using multi-class classification, you want to predict single tag per image. Let's look at a few best practices with respect to custom vision. Number one, pick the domain closest to your scenario. Whether you're using classification or object detection, it is possible to choose the domain when you are creating the project. Make sure that you choose the domain which is closest to your specific scenario. So different domains are available for classification and object detection projects. The next two best practices are applicable to any image-related artificial intelligence or machine learning projects. You need to have sufficient images. The minimum that custom vision needs is, if you want to make use of a tag, there should at least be 15 images with that specific tag. However, to have really good predictions, the recommendation is to have thousands of images. The more images you have, the higher will be the accuracy. So if you want to improve the accuracy of a machine learning model which is based on images, the first thing that you can try is to add more images. And make sure that these images are captured from different angles in different lighting, so that there is sufficient variety in your images. So having sufficient images and having sufficient variety in those images is very, very important when it comes to building machine learning models around images. Now that we played around with custom vision, let's go ahead and delete the project. So as usual, we'll go to the resource group. So let's go to resource groups. And the custom vision RG is the resource group that we have created for all the resources related to custom vision. So let's go ahead and say delete resource group, custom vision RG, and say delete. Cool. The deletion of the resource group is triggered, and I'll see you in the next step with another service. Welcome back. As we discussed until now, traditional programming is based on rules. If this, then do that. So you have programmers who are coding these specific rules. And machine learning is all about learning from examples, learning from data. You have a set of images, you tag them, that becomes your data, and you can use it to create your model. Or you have a table like this, where you have a history of home prices, and you will use that to create a model. Let's now dig deeper into the creation of the model. Let's look at a couple of important terminology which are typically used when it comes to machine learning. Features and labels. What are features and what are labels? Our goal with machine learning is to create a good model. You give it the right inputs, it would be able to generate the right prediction. So you'd give inputs to a model, and the model returns a prediction back. The specific parts of the data which are important to make the prediction, these are what are called features. And whatever prediction you are generating is called a label. This is very, very important to understand. The inputs which are really important for the model to make a prediction are features. Whatever prediction the model is making is a label. Let's consider the house price prediction model. What is the thing that you are trying to predict? It's the price of the house. So the label is price. And the features are all the things that you would need as inputs to be able to make that prediction. For example, the area of the house, how many rooms are in it, how many bedrooms are there, how much furniture is there, which floor the house is on, what is the age of the house. Whatever things are important to make that prediction, these are called features. Whether the building has a balcony or not, these are all features. Let's look at a few more examples for features and labels. Let's consider a used car price prediction model. What is the label? The label is easy. Again, it's a used car price. The features might be varied. Who is the manufacturer of the car? What is the year? What is the model? What is its age? What is the condition of the car? How many cylinders? Where the location, which city or country? All these are very, very important in predicting a used car price. So the label is price, and these are the important features. Let's look at another example. Spam email classification model. So you'd want to create a model to be able to classify whether a specific email is a spam or not. The label is spam or not. What are the features? Typically the features that you have is who is the sender, what is the subject, what is the content, and maybe a few more things like that. Let's consider another example. Grant a loan model. The label should be grant a loan. What are the features? These are just a few examples, maybe credit score, or does the person own a car? Does the person own real estate? Is the person married? Does the person have children? What's the total income? What is the total credit? All these might be the factors you might want to consider before you decide to grant a loan or not. In this step, we looked at a couple of terminology which is typically used in machine learning. Features and labels. The inputs which are made use of the model to make the prediction are called features. The prediction generated by the model is called a label. It's very important to understand what is label and what are features, and that's why we added in a lot of examples to make sure that you clearly understand that. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. Now that we understood what is label and what are features, let's now switch our attention to technique. Depending on the type of model you would want to create, depending on the prediction you would want to make with a specific model, you can choose the specific technique that you can use to generate your machine learning model. Let's quickly get an overview of the important techniques. The first technique is called supervised learning. When you're doing supervised learning, you have both features and labels. So you have inputs and there is a predefined expected output. Think about different machine learning problems. What could be the output you would want? For example, I want to predict the amount of rainfall next year. This is a numeric value we would want to predict. So if your label or the prediction is a numeric value with a range of possibilities, in those kind of situations, your problem is classified as regression. If the output from a model is expected to be a number with a range of possibilities, let's say the value can range from 1 to 10,000. So if there are huge range of possibilities that are possible for your output or the prediction or the label, then you're going to use regression. Examples are used car price prediction, house price prediction, predicting sea level. What would be the sea level at the end of the year? What would be the sea level at a particular time in future? Predicting how many vehicles are using a specific highway. These are all examples of regression. The output in all these cases is a numeric value which has a huge range. How much will it rain tomorrow? That's another example of regression. The next type of output you might have from your machine learning model is a yes or no type or a classification kind of a thing, where you'd want to determine whether it's 0 or 1, yes or no, whether it's type 1, type 2, or type 3. These kind of problems are called classification problems. Label has a limited set of possibilities. Let's say you would want to predict if the traffic light is red or green or yellow. That's a classification problem. Let's say you want to predict whether an email is spam or not. It's a yes or no. You want to predict whether you want to grant a loan or not. You want to predict the specific type of a cloud. These are all classification problems. Will it rain today? Yes or no? That's also a classification problem. So classification problems have limited set of possibilities for labels. Regression problems, on the other hand, have a huge range of possibilities. So in summary, whenever you talk about supervised learning machine models, you have an output, and if your output is predicting a category, or you are saying yes or no, or 0, 1, or 0 or 1, or type 1, type 2, type 3, in those kind of situations, you are having a classification problem. If you are predicting a numeric value, then it's a regression problem. The other ML technique is unsupervised learning. In unsupervised learning, you will not have any labels. A good example of unsupervised learning is clustering, where you divide customers into groups. You have 100 customers and you'd want to group them into certain number of groups based on similarities between them. Over here, there is no specific output as such. You just want to divide them into groups. These kind of problems are called clustering problems, where there is no label. So you'd want to group similar entities based on their features. In this step, we looked at two machine learning techniques, supervised learning and unsupervised learning. If you have a specific label that is the output of our model, then we are doing supervised learning. If the label is numeric value, which can have a huge range of possibilities, we are doing regression. If the label can have only a limited set of possibilities, then we are doing classification. If your model does not have any output, there is no label from a specific model, then you are doing unsupervised learning. Examples are dividing customers into groups, grouping similar entities based on their features. This is what is called clustering. Let's discuss more about this in the next step. Welcome back. In the last steps, we understood a couple of very important fundamentals about machine learning: labels, features, and we also discussed about supervised learning and unsupervised learning. We also looked at three types of machine learning problems: regression, classification, and clustering. As far as this exam goes, it's very, very important to understand these. And that's the reason why we'll look at it in depth using a few scenarios. So you're doing house price prediction and you'd want to categorize these into features and labels. So you have price, area, rooms, and age. Which of these are features and which of these are labels? You want to predict house price. So house price is a label. And if you think all the others are important to determine the price, then all these become features. So area, rooms, and age can be features. Categorize into features and labels for used vehicle price prediction: manufacturer, year, model, age, condition, cylinders, location, price. Your guess is right. So the price is a label. All the others can be features. Let's now switch our attention to identifying the specific type of problem. We would want to identify whether something is regression, classification, or clustering. If something is regression or classification, then it's supervised learning. If something is clustering, then it's unsupervised learning. So you'd want to predict used car price. It's a regression problem. The price can have a huge range. Spam email identification. You want to identify whether it's spam or not. There are only two outputs possible. There are only two labels possible: yes or no. So it's a classification problem. Predict amount of rainfall in the next year. You want to predict the amount of rainfall in the next year. It's a regression problem. If you want to predict if it will rain tomorrow or not, then it's a classification problem. However, if you want to predict the amount of rainfall, then it's numeric. It can have a huge range of values. Then it becomes a regression problem. Should we grant a loan? There are only two outputs possible. So it's classification. Identify the type of vehicle in an image. There are only specific types of vehicles which are present. So I would call this a classification problem as well. Find a specific dance form in a specific video. Even this can have very limited set of values. So I would call this a classification problem as well. Divide customers into groups. Over here, there is no specific label you are trying to identify. So this becomes unsupervised learning, and you can use clustering. The goal behind this scenarios is to review some of the important things that we have learned in the last couple of steps. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. Now that we understood some of the important concepts related to machine learning, let's now focus on the different steps which are involved in creating a machine learning model. You want to create a machine learning model. What are the different steps which are involved? That's what we'll be looking at in the specific step. The first step is to obtain data. To create the model, you need a lot of data. You might want to import the data from an on-prem database, or you might want to import the data from a data set which is available online, or you might want to import data from a cloud database. Whichever approach you take, you need to have all the data available first. The second step is to clean the data. If there is missing data, or if there are rows where something is null, you'd want to take care of all those things. Maybe you want to delete those rows, or you want to make sure that correct data is entered in those rows. You also want to ensure that there is sufficient variety of data that is present. For example, if you are creating a model to identify fruits which are present in a specific image. In those kind of situations, your data should contain images containing all the different types of fruits. So there should be sufficient variety of images containing all the different types of fruits. And you should have sufficient images for each of the fruits as well. So these two steps are two of the most difficult and the most important steps in machine learning. Obtaining data and making sure that it's clean and it has the right amount of variety is one of the most important parts of machine learning. Once you have the data, you would get to feature engineering. Your dataset might have 100 columns, but all the 100 columns might not be important to do machine learning. You want to identify the right set of features which are important for your model. You also want to identify what is the output, what is the label. Feature engineering is pretty complex. You might have multiple columns in your data. You might want to combine some of these columns into one feature, or you might want to actually split a column into multiple features. So there are a lot of things that you might want to do as part of feature engineering. So during feature engineering, you take the raw data and you convert it into data where you have clearly identified features and label. Once you have the features and label identified, you'd know what kind of problem you are doing. You might be doing a classification problem, a clustering problem, or a regression problem. Based on the specific problem, you would choose the right algorithm and you would do the training. The output of training is a model. So whenever you are doing some training, the inputs are data set and the specific algorithm, and the output is a model. Once you complete the training, you have a model which is ready to use. Will you use it directly in production? Nope. You'd want to evaluate that specific model. You'd want to evaluate the accuracy of the model. That's what you would do in step 5, which is model evaluation. There are different metrics that you can use to evaluate a model. What you typically do is to repeat steps 4 and 5 with different algorithms. Let's say you have a regression problem. There are a number of regression related algorithms. So you would create multiple models with each of those algorithms and then evaluate which of the models is giving you the best performance. So you would repeat steps 4 and 5 and identify the right model which is giving you the right amount of accuracy. And that's when you would go for deployment. You would deploy the model to production for use. In this step, we looked at the important steps in machine learning at a high level. The first two steps are to obtain and clean data. The third most important step is to do feature engineering. You want to convert raw columns of data into features and labels. Sometimes you would want to combine columns, split columns, or normalize data. You want to do a lot of different things to identify the features. Once you have identified features, labels, and you have the data ready, you'd want to create a model. To be able to create a model, you need the data set, and you'd want to identify the specific algorithm to use to create the model. Once you have a set of models, you'd want to evaluate them. That's what is done in step 5, model evaluation. Once you are happy with the accuracy of the model, you can deploy it to production and make inferences. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's review some of the important terminology related to machine learning. In the last few steps, we learned a lot of different terminology. Let's quickly review some of it and also add a little bit of new terminology. Let's look at the important process related terminologies. One is training. The process of creating a model is what is called training. What is evaluation? Evaluation is the process of checking if the model is working. And the third process related item is inference. Inference means using the model to do predictions in production. So after deploying the model, you are using the model to make predictions in production. That's what is called inference. As we discussed, the data which is used to create, validate, and test the model is what is called dataset. The dataset would contain features and label. Features are the important inputs, and the label is output or the prediction. There are three different types of datasets: training dataset, validation dataset, and testing dataset. To be able to create a model, you need to provide the right dataset to the algorithm. The dataset which is provided to the algorithm is called training dataset. The dataset which is used in the evaluation phase, the dataset which is used to validate the model, is called the validation dataset. In the typical machine learning cycles, you might want to test multiple algorithms. So you'd create multiple models using different algorithms using the same training set, and then you would use the validation dataset to evaluate the performance of the model. So the goal of validation is to identify the best model for your purpose. Once you have the best possible model, you'd want to do a final round of testing. That's where you'd make use of the testing dataset. You can think of validation dataset as the one which is used for system testing, and the testing dataset as the one which is used for UAT testing, or the final testing that you would do before you release your application to production. Typically, whenever you see any machine learning services, you'd have a service to split data. So the reason you'd want to split data at the start itself is because you'd want to separate training data from your validation data. You don't want to use the same data for training and validation. You would want to ensure that these are two separate things. And that's the reason why if you have 10,000 rows, probably you would take some of them as training dataset and take some of them as validation dataset. In this step, we learned a few more terminology related to machine learning. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In the last few steps, we looked at some of the machine learning terminology and some of the important stages in creating a machine learning workflow. Let's review some scenarios related to that in this specific step. Determine the ML stage. You want to remove data having null values from your dataset. Which stage would you do this? This would be in the data preparation stage. You'd want to clean data. Normalize or split data into multiple features. There might be some scenarios where you might want to split a specific column into multiple features. This would be done as part of feature engineering. Next scenario. When you evaluate the accuracy metrics of a model, you do that during model evaluation. Typically when you start with a machine learning problem, you don't know which algorithm will give you the best results. And that's why you'd create a number of models using different algorithms, and you will evaluate those models. You will evaluate the models based on a number of metrics, and you choose the right model for your problem. Let's now shift our attention towards terminology. Using a model to do predictions in production. What is this called? This is called inference. The process of creating a model. This is called training. Dataset used to train or create a model. It's called training dataset. Dataset used to evaluate a model. Once the model is created, you want to evaluate it. That's when you'd use the validation dataset. Dataset used to do final testing before deployment. So this is kind of the UAT testing dataset. That's the testing dataset. In this step, we looked at some of the important scenarios related to machine learning stages and some of the basic terminology. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In the previous steps, we understood the terminology related to machine learning. We saw that doing machine learning is very, very complex. We saw that there are multiple steps involved. There are multiple processes involved, multiple data sets. You might want to create multiple models. You would want to evaluate them. You'd want to deploy the model. So there is a lot of complexity around machine learning. The service which Azure provides to help you create your machine learning models in a very easy way is Azure Machine Learning. Azure Machine Learning simplifies the creation of your models. You can manage data. You can manage your machine learning code. You can manage the compute devices which are needed to run your machine learning workloads, and you can manage your multiple models. You can prepare your data, so you can edit your data sets, you can train your models, you can publish models for use, and you can monitor the performance of these models as well. An awesome thing about Azure Machine Learning is that it provides you with a couple of options to create models. One is automated machine learning. This is where you can build custom models with minimum machine learning expertise. Even if you don't have a lot of machine learning expertise, you can go ahead and use automated machine learning and build a custom model using your data. The other option you have is to make use of Azure Machine Learning Designer to create custom models. You can build your own models. You can build your own pipelines without writing any code. So if you have a team which is familiar with machine learning and if you want to build models, you can use the Azure Machine Learning Designer. However, if you have a team that does not have any ML expertise, however, you'd want to create custom models, you can try and use automated machine learning. Let's quickly look at a demo for machine learning. If you type in machine learning, you can pick up machine learning in here. So this is machine learning. This is where you can go in and create your workspace. So if you want to manage your machine learning solutions and you want to manage the entire data science lifecycle, you can create a machine learning workspace using Azure Machine Learning. So let's get started with creating a machine learning workspace. As usual, choose the subscription. Make sure that you create a new resource group. I'll call this Machine Learning RG and say OK. I would need to give a unique workspace name as usual. So I'll call this Machine Learning in 28 min. There are a lot of things that are automatically created. To make use of machine learning, you need data. The data is stored in storage account. If you want to store any secrets and things like that, we can use the key vault. Let's take the default for all the settings in here and let's go ahead and say review and create. And let's go ahead and say create now. In this step, we understood the basics of Azure Machine Learning and we started the process of creating a Azure Machine Learning workspace. I'll see you in the next step. Welcome back. In the last step, we kickstarted the creation of machine learning workspace. The deployment took about 10 minutes and right now it's ready. Let's say go to resource and go over to the machine learning workspace. This is where you can manage your machine learning lifecycle. And from the machine learning workspace, what we'll do is we will go to Azure Machine Learning Studio. If you want to build, train, evaluate, and deploy machine learning models, you can make use of Azure Machine Learning Studio. You can launch Azure Machine Learning Studio directly from our workspace. So let's go ahead and say launch Studio. It would take a little while and it would log you into Azure Machine Learning Studio. As you can see in here, you can register data, you can train models, you can evaluate models, find the best model, and then you can deploy the model as well. So Azure Machine Learning helps you to build, train, deploy, and manage your models at cloud scale. I don't want to go through the tour, so I'll close this. When you go in here, you would see three important things. One is notebooks. The second one is automated ML. The third one is designer. If you have a lot of data and you'd want to play with the data, you'd want to explore the data, you'd want to make use of a notebook, you'd want to write simple Python or R programs, and you'd want to explore the data. That's where you would make use of notebooks. The second option which is present in here is automated ML, automated machine learning. Your team might not have any experience with machine learning. In those kind of situations, you can use automated ML to automatically train and tune a model. Without having any ML expertise, your team would be able to create custom ML models. The third option which is present in here is designer. This is where you would create your complete ML pipelines. So your data engineers or data scientists would come in here, create the entire machine learning pipeline. You can customize a lot of things and create your own models. Before we would be able to run any of the machine learning workloads, we would need to provide it with compute. We would need a compute environment where we can run our workloads. Let's get started with creating a compute environment. The way we can do that is by going to compute. There are 4 different types of computes that you can create: compute instances, compute clusters, inference clusters, and attached computes. We'll talk about the differences between each of these a little later. For now, we would want to create machine learning models. We would want to be able to run automatic machine learning, as well as we would want to create our own custom pipeline. And to be able to do that, you would need a compute cluster. So what we'll do is we'll go ahead and create a compute cluster. So I'll go ahead and say new in here and kickstart the creation of the compute cluster. I'll choose the default location which is suggested. I would want to have dedicated virtual machines. I would use virtual machine type as CPU. I would choose the recommended option for virtual machine as well. Standard DS3 V2 should be sufficient. This costs about $250 per hour. So what I would recommend you to do is to do the machine learning workloads and immediately terminate this. So don't have this compute running for a long time. This can get expensive. So what we'll do is, as soon as we are done with all this stuff, we'll immediately delete the entire resource group that is associated with machine learning. Let's go ahead and say next. On next screen, you need to enter the compute name. So I'll call this machine learning compute. I'll call this ML compute. I would say the minimum number of nodes is 0. I will leave the maximum number of nodes at 1. And what I would do is I would reduce the idle seconds before scale down to 900. If it's idle for 900 seconds or 15 minutes, the cluster can be shut down. I'll take the defaults for the rest of the things and I'll say create. The creation of the compute cluster would take a little while. While the compute cluster is getting created, let's go to datasets and create a dataset. We would want to create a machine learning model. And to be able to create a machine learning model, you need to have a dataset. So what we'll do is we'll make use of one of the open datasets which is available. So let's go to datasets and I'll go to register datasets. This is where you can manage, share, and track data in your machine learning workflows. So you can have common datasets across multiple different machine learning pipelines. So let's go ahead and say create dataset. And we would want to create it from open datasets. What we'll do is we will use a sample, one of the popular samples, which is related to diabetes. So I would use the diabetes sample, which is provided in here. As it says in here, this has 442 rows and there are 10 features. And this is ideal for getting started with machine learning. If you do a Google for diabetes dataset, Azure Open Data, you'd land upon this diabetes dataset. So as it says in here, 442 samples, 10 features. It's ideal for getting started with machine learning. If you click the original dataset description in here, you'd go to the home page of the data and you can find the real description in here. So basically what the dataset contains are 10 baseline variables: age, sex, body mass index, average blood pressure, and 6 blood serum measurements that were obtained for 442 diabetes patients. And the value we are predicting in here is the measure of disease progression 1 year after baseline. So you took the metrics and you are trying to predict what would be the level of diabetes or what is the response of interest at the end of 1 year. So you have these 10 inputs and you're trying to predict an output. If we talk in machine learning terminology, all these are features. And the last one is what is the label. This is what we are trying to predict. So let's go ahead and choose the sample diabetes dataset, and I'll say next. And I'll leave the name as sample diabetes, and I'll say create. So first we created the compute, and now we are focusing on the data set. So if you'd want to do any machine learning, you need some amount of compute. And if you want to create a model, you need a data set. So we are choosing the diabetes data set. If you click the data set and go inside, you'd be able to see a few more details about this data set. If you go to explore, you can look at the data inside the data set. You can see the different columns which are present in here and the different rows of data which is present in here as well. If you go to profile, you'll also look at a few metrics based on each of these columns. Whenever you are doing machine learning, understanding your data is very, very important. You want to make sure that your data is good. So you need to look at each column and make sure that you have appropriate data. And that's where profiling your data is very important. We have 11 columns, out of which 10 are features, 1 is our label, and we have 442 rows of data. Let's look at the first column, which is age. You can see the distribution of people in the data set. You can see that we have a lot of data in the age range of 49 to 55, and we have very less data for 73 to 79. In a good data set, you would have equal distribution for most of the age groups where you want to predict. In addition to the distribution, you can also see a few statistics related to that specific column. What is the min? What is the max? How many count of values? How many values are missing? And a few other stats on the right hand side. And you'd see that this kind of stats are present for all the columns. So for sex, BMI, blood pressure. So you can explore each of the columns and make sure that you have the right distribution of data for all of them. In this step, we got started with exploring Azure Machine Learning Studio. We would want to create machine learning models using automated ML, and we would want to create a pipeline using Designer. And to be able to do that, we would need compute and data sets. So we created a compute. The compute is now ready, and the data set is also now ready. Let's explore how to create a machine learning model in the next step. Welcome back. We want to create a machine learning model. And what we would do is we would use the easiest approach to create a machine learning model right now. The simplest approach is to make use of automated ML. Automatically train and tune a model using a target metric. Let's get started now. So let's say start now over here. And I would say I would want to create a new automated ML run. As you can see in here, automated ML can train and find the best model based on your data without writing a single line of code. So let's go ahead and do that. New automated ML run. And let's select the data set. So this is the data set that we would want to make use of. We already registered it in the last step. I'll go ahead and say next. The next thing we'd want to do is to configure the run. The process of creating a model is called an experiment. And over here, we can give a name to our experiment. So what I would call this is automated ML diabetes experiment. And you need to choose the target column. What is the thing that you are trying to predict? What is the label? That's what we would need to give. So I would choose Y as the target column. So the label is Y. That is what we are trying to predict. So all the other things become features by default. The next thing that you need to choose is this compute cluster. We already created a compute cluster in the last step. So let's choose that. And let's say next. The next step is where you would choose this task type. What are you doing? Are you doing classification, regression, or time series forecasting? Classification is to predict one of several categories in the target column. If you want to predict whether it's yes or no, or if you want to say the output would be between blue, red, and green. In those kind of situations, you are doing classification. What we are doing over here is we are predicting a value which can have a huge range. If you look at our label, which is Y, which is the prediction of diabetes level after a year, it has 72 unique values. So the value can range over a huge range of values. And that's why what we are doing in here is regression. Let's choose regression. Over here, you can configure a few additional settings. I'll click View Additional Configuration Settings in here. This is where you can configure what metric do you want to use to tune the model. Because we chose regression, one of the popular metrics to use with regression is normalized root mean squared error. We will discuss a little bit more about this a little later. By default, the training would make use of a number of algorithms. So what you are seeing in here are all algorithms which are related to regression. And what the automated ML run does, it would create multiple models using all these algorithms, and it would decide which is the best one for you. What I would want to do is to keep things simple. So what I would do is to add a few algorithms in here as blocked algorithms. Blocked algorithms are those algorithms we don't want to run. I don't want to run this machine learning thing for a long time. What I would do is I would want to allow only a couple of algorithms to run. And therefore, I would block most of the other algorithms. So I will leave the first 4 in here and block all the rest. So let's go ahead and block all the rest other than the first 4. You can actually randomly choose any of these. The choice of algorithms is not really important. It's important to understand the process of going through the whole thing. So let's leave 4 algorithms. So right now, these are the 4 algorithms which will be run. So let's leave them in. The next thing you need to choose is what is the maximum amount of time that you would want the training job to run. What I would do is I would choose this as 30 minutes or 0.5 hours. I don't want this training job to run for a long time. So I would choose 0.5 and I would take the defaults for rest of the thing and I'll say save. The next thing that you can configure is the featureization. Earlier we talked about the fact that once we have the data available, you'd want to do feature engineering. You'd want to select what are the columns which can be features. So you can decide which of these can be features. If you want, you can exclude some of them. And you can also do something called imputation. If there is some missing data, you can use imputation to fill that data. You can fill it with a number of different options. You can either fill it with the average, or you can fill it with the most frequent value, or there are a lot of other options like fill with constant, a specific value you'd want to fill it with. We don't want to really worry about imputation because most of our columns are filled with values. So let's take the defaults for this as well. Let's take the defaults here and I'll say cancel. We're all set to execute our first machine learning run. Let's go ahead and say finish. So this would create a new automated ML run. You can see that a random name is assigned to this and the status right now is not started. The creation of the machine learning model would take a lot of time. What I would recommend you to do is to take a break and I'll see you on the other side. Welcome back. We kicked off the automated ML run in the last step and the run took about 41 minutes to complete. As you can see, it takes a long time to run. We just chose a few of the algorithms and it took 41 minutes. And if we ran all of them, then it would have taken even longer. If you go to automated ML, you'd be able to see the details of the specific experiment that we performed. This was the first run of that specific experiment. Let's go ahead and click the display name of that specific run. You can see that the status is completed and you can see that all the data has been sampled. If you go to the models, you'd be able to see all the models that were created. To be able to evaluate the different algorithms, what automated ML does is it would create a model with each of those algorithms. You can see that there are a number of models which are created based on different algorithms. And it also evaluates these algorithms based on a specific metric. Normalized root mean squared error. That's the metric which is being used to evaluate. And you can see that this specific algorithm, the model which was created with it, has the least amount of error when validation was done. What we can do is we'll pick up this model and we can say if we would want to deploy this model. So we would want to use this model, we would want to create a deployment of it, and we would want to use that for inferences. So let's say AutoML model, and I would say voting ensemble. So that's the algorithm that was used to create the model. There are multiple options for compute. What I would recommend you to do is to choose Azure Container Instance, and you can go ahead and choose the defaults and say deploy. As you can see, we are making use of no code deployment. So automated ML helped us to create a model, and what we are now doing is we are deploying the model. If I go to the notifications, I can see that the deployment is now in progress. Once the model is deployed, you can go to endpoints to see the model in action. So let's go over to endpoints, which is the endpoints in here. And you should see a AutoML endpoint in here. What we can do is you can go in here. You can go in here and you can see that the deployment state is healthy. That's cool. So our deployment of the model has success. So our deployment of the model has succeeded. So you can go ahead here and you can start testing this specific model. So you can go in here and you can enter different values for age, sex, BMI, BP, S1, S2, S3, S4, S5, S6, and you can start testing it with real-time data. If you want to consume this programmatically, there is also a REST endpoint which is provided. So there's a REST endpoint which is provided. If you are writing a C# program or Python program or R program, there is code in here which will help you to talk to the endpoint and consume the model. In the last few steps, we made use of AutoML to create a model. AutoML makes it very, very easy to create and deploy a model. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. Now that we played with automated ML, let's shift our attention to Designer. We would want to create our own custom machine learning pipeline. How can we do that? That's where we can go to Designer. What I would do is I'd go ahead and click Start Now in here. There are a number of sample pipelines which are available in here. What we would do is we would create a new one. So I would say I would want to create a new pipeline. The pipeline page is now loaded up. So this is the pipeline canvas. You can bring in any of these modules which are present in here into the pipeline. So you can see that there are data sets in here. So if I would want, I can bring this data set into the canvas. So we are bringing the data set into the canvas of the pipeline. In addition to choosing the data sets, you can see that there are a number of other modules which are present in here. You can see that there are modules related to data input and output. You can import data from external sources. You can export data to external sources. There are modules related to data transformation as well. You can add rows, add columns. You can perform mathematical operations. You can clean missing data. And there are a lot of other operations that you can perform, like normalizing data, removing duplicate rows, and also split data. For me, split data is one of the most important operations in here. Whenever we want to create a model, we would want to do training as well as evaluation. We would want to create the model and evaluate the model. And for doing training and evaluation, we would want to divide the data set into two parts. That is what split data would allow us to do. So what we'll do now is drag split data in here. So the data that we have, we would want to split it into two so that we can use one for training and the other one for evaluation. If you scroll a little down, you can also choose the specific machine learning algorithms. When you expand that, you would see that there are three categories of algorithms which are present in here. The specifics of the algorithms are not really important. The important thing is to understand the three categories. You have regression algorithms, the clustering algorithms, and the classification algorithms. And the specific use case that we are having is a regression use case. And we can use any of the regression algorithms which is present in here. What I would do is I'll take the simplest of them, which is linear regression, and I'll drag it in here. So as you can see in here, you have the pipeline canvas where you can drag in different modules. You can drag in data sets, you can drag in data transformation related things, you can drag in the algorithms you would want to execute, and there are also things related to model training that you would want to perform. So if you want to create a clustering related model, you can use train clustering model module. If you want to create a classification or regression model, you can make use of the train model. So what we'll do is we want to create a model using regression. So I'll drag train model in here as well. There is a little bit of configuration that we would need to do for train model. We will do that a little later. For now, let's continue exploring the different modules which are present in here. So we now have the dataset, split data, and we have the algorithm we would want to run, and we have the training model thing in here. The next thing we would want to do is to evaluate the model. So we want to score and evaluate the model. So let's drag the things which are related to scoring and evaluating a model. We want to score a regression model. So let's add score model in here. I'll close this. The score model would help you to score your model, check how your model is performing with respect to a specific data set. And once we have the score model, we want to also evaluate the model. We want to evaluate the results related to the score. So these are the different things that we would want to do as part of our machine learning lifecycle. In addition, you can see that there are a lot of things which are present in here. If you want, you can run scripts related to Python language or R language, and you can run a number of things related to text analytics, computer vision, recommendations, anomaly detection, and you can also expose the model as a web service. At high level, what we are creating in here is a machine learning pipeline. And to create a pipeline, what we are doing is we are dragging multiple modules into the canvas. The first thing which we dragged in is the dataset. What do you want to do with the dataset first? We want to split it into two. We want to split the data into training dataset and validation dataset. That's why we brought the split data module in. So let's drag from here and drag it until here. Let's click it and drag until here. And then you would see that a connection is established. So you just need to click it, hold, and drag it until here. You would see that now the dataset is going into split data. In split data, you can configure how to do the split. I can say I would want to do half and half. Half data for training and half data for validation. Over here, we have less amount of data. What I would do is I would put 80%. So I would want to use 80% of data for training and rest 20% for validation. And I'll take the defaults for the rest of the things and say close. Once you have the data, what I would want to do is to do the training of the model. So we split the data. After splitting the data, we would want to train the model. Let's zoom in a little bit in here. And let's focus on this part. So to train the model, what you would need is two different things. One is the algorithm. The other one is the data. So what I would do is I would click in here, click the algorithm and drag it to the model left-hand side thing. So we have connected the algorithm and now I would go ahead and connect the data. So the first part of the split data is the data which you can use for training. So the training data, I would want to pass it to train model. And you can click this now and you can select the label column. What is the label column? We are using the diabetes data. You can go in here, go to label column, say edit column, and go and choose the right column name. And the column name that we want to have as label is Y. So that's cool. Let's go ahead and say save. So this is the output column. All the other ones becomes input columns or features. If you want to have explainability for your model, you can also choose true. I'll take the defaults for rest of the things and I'll close this. Once you have the train model ready, you want to execute the model against the rest of the data. You want to run it against the validation data set. So I'll pass the model from here to core model, and I'll pass the data from split data to here as well. Once we run the model against the validation data set, we would want to evaluate it. So I'll take the results from score and put it to evaluate. As you can see in here, building a machine learning model is not very difficult. It's just about dragging a few modules here and there and connecting them all together. The most important part in here is choosing the algorithm. Choosing the algorithm needs a lot of machine learning knowledge. You need to be an expert data engineer or expert data scientist to be able to choose the right algorithm for a specific problem. The other challenge typically is the data. Getting clean data and being able to identify the right features in there is also very, very complex. Other than that, the entire process around creating a pipeline is very simple. And that's what we are seeing in here. So we have now created a simple pipeline. This is a pipeline for regression. If you want to do classification, the only thing that would change in here is instead of the regression algorithm, you'd bring in a classification algorithm. Other than that, most of the other steps would remain exactly the same. So let's go ahead and now rename this pipeline. So I'll call this custom ML pipeline. And now let's go ahead and submit it. When I try to submit it, it says select compute target in settings panel. I'll click this, and over here I can go and select the default compute to use. Let's go ahead and say select compute target and go ahead and choose ML compute, which is present in here, and say save. This is the same compute which we used earlier for automated machine learning. We are also using this to run our custom ML pipeline. Let's go ahead and say submit. And what we are doing now is to run the pipeline. So to run the pipeline, we'll create an experiment. So what I do is create a new experiment, and I'll call this custom ML experiment. And I'll say submit. Within a little while, you'd see that the pipeline would shift to running status, and each of these steps in the pipeline would be executed. I'll see you in the next step where we'll look at the results of the pipeline execution. Until then, bye-bye. Welcome back. In the last step, we kicked off a run of our pipeline. If I go over to experiments, I should be able to see an experiment that we have created in the last step. It's the custom ML experiment that we created. If you go in, you'd be able to see the different runs for that specific experiment. You can see that the last one took about 10 minutes. Let's pick that run up. And you can see the details of each of the steps inside that specific run. So let's close all these pop-ups which come up, and you can see the details of what are the steps which are there in here. You can see the graph. You can see the different steps which were part of the run. You can see the output and logs in here. If you go back to the graph and go down and go to evaluate model and do a right click and say preview data and evaluation results. I'll make this full screen. I'll say maximize panel by clicking this in here. You can see that the rows are 1 and the columns are 5, and mean absolute error is 43 and the root mean squared error is 52. Now, what are these metrics? Why are these important? Whenever we are making use of regression, we are predicting a numeric value. Let's say the red line in here is the predicted value, and the dots in here are the actual values. So the red line indicates a graph of the predicted values, and the dots in here, the specific dots in here, are the actual values from the validation data set. The black line over here is the distance from the predicted value to the actual value. This is nothing but the error for that specific prediction. So your model predicts that the value is 45, but according to my validation dataset, the value should be 40. So there is an error of 5. These error values are what are used to evaluate the models. There are different kinds of metrics which are generated based on these error values. These metrics are very, very complex. You don't need to understand each one of these metrics in depth. A high-level overview of understanding that this metric is specific to regression, this metric is specific to classification is more than sufficient. So let's look at the metrics. Mean absolute error. How close is prediction to actual value? And you take an average of all those. So if we are making 6 predictions, then you take all the errors and you take an average of them. That's the mean absolute error. It's also called MAE. This is important in regression because in regression we are predicting numeric values. Obviously, the lower the better. Along with mean absolute error, there are a couple of other mathematical metrics which are used for regression-based models. And one is mean squared error and the other one is root mean squared error. Mean squared error is MSE, root mean squared error is RMSE. So instead of directly taking an average of each of these values, what mean squared error does is it squares each of these values. If this is 5, if the error is 5, it does 5 square. If this error is 10, it does 10 square. Over here it's 3 square. So each of these errors is squared and you add them up and then you average it. So it's the average of squares of the distance between actual and predicted. In some scenarios, you don't want large prediction errors. If the value of house is 1 million, if the prediction is 2 million, that's a large error. Maybe that model is doing well with 90% of the values and giving the right values, but for 10% of the scenarios, it is giving very, very large predictions. When you average them out, the model might have a good score, but when you don't want large prediction errors, in those kind of scenarios, you can go with mean squared error. So you square the error and calculate the average of it. The mean squared error will be a huge value because you're squaring things. And that's where you would use root mean squared error, which is just a square root of that value. If the mean squared error value comes to 100, you would do a square root of it, which is 10, and you would calculate root mean squared error. With all these values, the lower the value, the better. The exact details of mean absolute error, mean squared error, root mean squared error are not really important as far as the exam is concerned. Having a high-level overview is more than sufficient. In regression models, what we are really concerned about is error. What is the quantity of error? What is the difference between actual and predicted? And there are metrics like mean absolute error, mean squared error, and root mean squared error, which are used to evaluate a specific model. Over here, you can see some of these values. You can see mean absolute error is 43. So the average difference between the predicted and the actual value is 43. The root mean squared error is 52. When you square each of the errors and find the average of them and do a root of it, it's 52. So these are the evaluation results of the model. If you're happy with these results, what you can do is you can go ahead and publish the model as well. So you can go ahead and publish the pipeline and you can create a new endpoint. So I'll say create new pipeline endpoint and you can go ahead and publish this. So you can go ahead and see the endpoint for that specific pipeline. So you can click this pipeline thing in there. And you can look at the details of the published pipeline. You can see that a REST endpoint is present in here. And you can also see a little bit of documentation in here. So if you click the REST endpoint documentation, you can see how you can actually send a request to that specific pipeline. So if you want to make a prediction, you can make use of this endpoint and submit a request to it to do the prediction. Let's close all of this. In the last couple of steps, we created a custom pipeline using Azure Machine Learning. We ran the pipeline, we created a model, and we also published the pipeline. Let's explore Azure Machine Learning further in the next step. Welcome back. In the last step, we saw how you can do evaluation for regression model. We saw that there are a lot of error metrics. So mean error or root mean square error, those are the kinds of metrics which are used to evaluate regression models. Now, how do you evaluate classification models? Classification models are much easier to evaluate. Why? Because there are very few possible results. Let's take the easiest of the classification models, which is two-way classification. Output is either yes or no, or 0 or 1, or negative or positive. Let's start with looking at some of the terminology. Predicted label. What's predicted? So if you are running a model and there is an output from it, that's predicted label. What is the data that is expected? That's true label. So according to your validation data set, what is expected? That's your true label. Whatever you are seeing in here is a confusion matrix. A confusion matrix is a matrix matching predicted label versus true label. So this is the prediction and this is the actual. Let's understand this in a little bit more depth. Let's say I'm predicting something and the actual value should be that it's negative. It should be 0. And let's say the prediction also comes out the same way. Then it's a true negative. So two negatives. So actual is negative, prediction is negative, it becomes a true negative. If actual is negative, but the prediction comes as positive, then it's called a false positive. The prediction is positive, but it should have been negative. So it's a false positive. So it's like you do a test, the test result comes out to be positive, but it should have been negative. And that's why it's called a false positive. Understanding this is very, very important as far as the exam is concerned. I would recommend you to have a clear understanding of what is true negative, what is false positive, what is false negative, and what is true positive. So true negative is when actual and prediction are negative. False positive is when prediction is positive, but it should actually have been negative. What is false negative? False negative is when prediction is negative, but it should have actually been positive. And true positive is when both actual and prediction are positive. You can see that all this terminology is from the perspective of the prediction. So true negative is when prediction is negative and the actual is negative. False negative is when the prediction is negative, but the actual is positive. The same is the case with false positive and true positive. False positive is when the prediction is positive, but the actual is negative. True positive is when your prediction is positive and the actual is also positive. Now think about this. What should be the values if you have created a perfect model? You have created a perfect model where everything is working fine. What should be these values? The true negative should be a high value. True positive should be a high value. False positive and false negative should be 0. Then you have the perfect model. And as usual, when it comes to the real world, there are no perfect models. That's where you need to make trade-offs. Let's take the case of false positives and false negatives. False positive is when an email important to me is marked as spam. That's a very, very big problem. If it's a very important email, I might miss it. However, if it's false negative, if it's a spam, but it's not marked as spam, that might not have so many consequences. What I can do is I can help Gmail by marking it as spam. Similarly, you can evaluate the other use cases as well. For some use cases, it might be okay to have a few false positives. And for other use cases, you should have 0 false positives. And that's the reason why there are different metrics consolidating these 4 values: accuracy, precision, recall, and F1 score. The details of these metrics are not really important. It is sufficient if you remember what is true positive, what is false positive, false negative, and true positive. And if you understand that accuracy, precision, recall, F1 score, these are all related to classification models. Now, what is accuracy? Accuracy is proportion of accurate results to total cases. How many did the model get right versus total? So it's very, very simple, right? Which are the ones which the model got right? It's true negative plus true positive. So it's true negative plus true positive by total. Precision is only based on positive. So it's true positive by the total of true positive plus false positive. Recall, on the other hand, is based on these 2 values, true positive and false negative. It's true positive divided by true positive plus false negative. F1 score has a complex formula. When you want a balance between recall and precision, you can go for F1 score. As the number of false positives increases, the precision decreases. As the number of false negatives increase, recall decreases. And F1 score provides a balance between these 2. So depending on your use case, you can choose any of these metrics. The important thing that you need to remember from this step as far as the exam are concerned are the concepts of true negative, false positive, false negative, and true positive. And also the fact that accuracy, precision, recall, F1 score are some mathematics around these 4. and the fact that these are used in classification models. I'm sure you're having a wonderful time, and I'll see you on the next step. Welcome back. In this step, let's look at a few important scenarios related to model evaluation in machine learning. Let's look at the terminology. What's predicted? What do we call that? It's called predicted label. What's expected? That's called the true label. So true label is what is expected, and predicted label is what is predicted by the model. Next, a matrix matching predicted label versus true label. What do we call it? We call it the confusion matrix. Confusion matrix has true positive, true negative, false positive, and false negatives. And there are a number of metrics around these. Confusion matrix is typically used in the case of classification problems. So what are the typical model evaluation metrics for classification problems? They are all metrics that are based on true positive, true negative, and false negative. These are accuracy, precision, recall, and F1 score. What are the model evaluation metrics for regression models? These are all based on the error in prediction. You are predicting a numeric value, and there is a possibility of an error in the prediction. And all these metrics are based on the average of the error, or average of the squares of the errors, or root of the average of the squares of the errors. So you have metrics like mean absolute error, mean squared error, root mean squared error. Anytime you see error in there, we are talking about evaluation metric for regression. In this step, we looked at some of the scenarios related to modal evaluation. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. Having played with Azure Machine Learning, in this step, let's focus on reviewing the terminology which is related to Azure Machine Learning. There is some important terminology that you need to remember with respect to the exam. Let's review that in the specific step. Studio. Studio is basically the website we are using to create our pipeline. So we went to a specific website for creating our Azure Machine Learning pipeline, running it. We are also able to do automated machine learning from there. That's Azure Machine Learning Studio. Workspace is the top level resource for Azure Machine Learning. When we wanted to create a Azure Machine Learning service, we went to Azure Machine Learning Service and created a workspace. And inside the Azure Machine Learning workspace, we made use of Azure Machine Learning Designer to create our pipeline. It's a drag and drop interface to create our ML workflows. And the Azure Machine Learning Designer provides us with a canvas. We dragged different modules into the canvas and played around with them. Pipelines are nothing but reusable workflows. You can do training and you can do retraining as well. Datasets are how you manage your data. Module is an algorithm to run on your data. We looked at the fact that there are different kinds of modules. Data preparation, machine learning algorithms were available as modules. We also had modules which would help us to build and evaluate models, model training, model scoring, model evaluation. The other important parts were compute. If you want to do training, you'd want to run it on a specific compute. There are 4 types of compute which are offered by Azure Machine Learning. These are compute instances, compute clusters, inference clusters, and attached compute. The most important thing for machine learning is training. And if you want to do training, you can make use of compute clusters. If you have data scientists and if you want to create development machines so that they can run notebooks, you can create compute instances. If you want to deploy your machine learning model for production, you can create inference clusters. In machine learning, you can also run a few other things. Let's say you want to run a Hadoop job, or you'd want to run a Spark job. You can make use of HD Insight or Databricks. In those kind of situations, you can make use of attached compute. The goal of this step was to quickly review some of the important terminology related to Azure Machine Learning. Let's now go ahead and delete all the machine learning related resources that we have created in the last few steps. So what I would do is I'll close all the windows. I don't really need any of them. I'll go to portal.azure.com. Let's go to resource groups as usual. So let's go to resource groups, and there is just one resource group that I have active right now, machine learning resource group. All the machine learning resources were created as part of that. So let's go ahead and say delete resource group. And let's go ahead and say delete. You can see that there are a lot of resources that are part of this. So let's delete all of them and get rid of them right away. So the deletion of the resource group is now in progress. I'm sure you had a wonderful time learning about Azure Machine Learning, and I'll see you in the next step. Welcome back. In this step, let's look at a few scenarios related to creating custom ML models in Azure. Let's get started with the first one. You would want to create custom models using your own images. Which service do you recommend? It's easy, Custom Vision. What is the website you made use of to create your Azure machine learning pipelines? We started in Azure Portal and then we went into Azure Machine Learning Studio. So Azure Machine Learning Studio is where you can create the pipelines, you can play with automated machine learning, and you can use the designer. Drag and drop interface to create your machine learning workflows. What is that? It's the designer, Azure Machine Learning Designer. Reusable workflows for training and retraining. It's a pipeline. Data used for training. It should be easy. Data set. What are the components that can be dragged onto a canvas to build a pipeline? What are the different things that you can drag on? Modules. There are different kinds of modules. Data sets are modules. You have machine learning algorithms as modules. You have modules for training, scoring, evaluation, and a lot of other things. What are the training machines for Azure machine learning called? They are called compute clusters. Let's look at a few more scenarios. What are the deployment machines for Azure machine learning called? These are called inference clusters. You use compute clusters for training and you use inference clusters for deploying your models. Why do you split data when you build a ML model? We saw that there's a module called split data, which helps you to divide the data set into training data set and validation data set. Why do you do that splitting? Because you want to use a part of it for training and rest of it for validation of a model. How can you consume an Azure machine learning model? You can publish it and you can access it as a web service. There is a REST API endpoint which is provided. You can send a request to it and get the right response back. What are the languages which are popularly used with machine learning? The languages which are popularly used with machine learning are Python and R. You want to version your models. You want to store them. You want to organize and keep track of your trained models. In Azure Machine Learning, there's a feature called model registration. So you can go and register your models and you can save them and you can keep track of these models over a period of time. In this step, we looked at some of the important scenarios related to the services related to building custom ML models in Azure. The two important services for building custom ML models are Custom Vision and Azure Machine Learning. I'm sure you're having a wonderful time and I'll see you in the next step. Welcome back. In the last few sections, we played around with a number of AI related services in Azure. AI is very, very powerful, but you need to be very, very cautious when using AI. Let's look at some of the most important AI considerations in this specific section. What are the challenges in building AI solutions? Number one is the importance of data. Your data should be good. Your data should be clean. Your data should represent all groups. If there are 10 possible results, all the results should be equally represented in your data. Some of the times, old data has bias built into it. If you go to Google and do a search for AI bias, you would always see news like this. AI bias causing 80% of black mortgage applications to be denied. If the data has bias, the bias can affect your machine learning model. That's something which you should always remember when it comes to machine learning. So the solutions you are building might not work equally for everyone, and that's not cool. Obtaining the right data for your use case might be a big challenge. Another important challenge is the fact that AI is still evolving. What if an AI system causes errors? What if a self-driving car makes an error? Another problem is the scarcity of skills. There is scarcity of data engineers. There is scarcity of skilled data scientists. There are also challenges associated with the ML life cycle. It's not like you create a model once and use it for your lifetime. As your data changes, you need to update the data sets and update your models to reflect the reality as of today. So there is a lot of life cycle involved with machine learning. There are also challenges with respect to security. Machine learning needs a lot of data, and you'd want to make sure that this data is securely used. You have the right permissions to make use of this data. Another challenge is the explainability of these solutions that we are building. A model might give you a label, but how can you explain the output? The last challenge is who will face the consequences, who's liable for AI-driven decisions. The creator of the AI model cannot say, I had wrong data. Somebody has to be liable for it. And that's where there is a lot of discussion on responsible AI principles. The goal is AI without unintended negative consequences. What are the important AI principles? The first principle is fairness. Fair to all groups of people. AI systems should not discriminate, should not have a bias towards gender, race, sexual orientation, or religion. There should not be a bias towards a specific group or individual. Your AI solution should be fair to everybody. A very important part of ensuring this is to ensure that your data should also reflect diversity, and your model should evolve with time. You cannot create one model and use it for a very, very long period of time. Your model should evolve as and when your data changes. The second principle is reliability and safety. You want your AI model to work under high loads. You want your AI model work even when there are unexpected situations. Let's say you're building a self-driving car. What happens in bad weather? What happens if GPS is down? What happens if data is bad? There are a lot of problems that can happen. So whenever you're building AI solutions, always think about what can go wrong. Make sure that you test all the possible situations. The third important principle is privacy and security. If you are using some data, you should make sure that you have the right to access that data. You should make sure that the people that data belongs to have given you the right permissions to use that data. And it's your responsibility to keep the data secure as well. Privacy and security is not something you can add at a later stage. It is a very important consideration from the day zero of an AI project. The fourth principle is inclusiveness. Nobody left out. Leaving out a certain set of people, example, people with disabilities, people who cannot see, hear, or talk. If your solution does not help people with disabilities, then you are violating the inclusiveness principle. Number 5 is transparency. When your model makes a prediction, you should be able to explain that prediction. And if there is something wrong, your developers should be able to debug it. You should be able to provide a clear explanation of users on why a specific decision has been made. Number 6 is accountability. Your solutions should meet all the ethical and legal standards. And you are the one who is responsible for the final decision your AI system makes. AI is not the final decision maker. An enterprise, a team, or a person is the final decision maker. In this step, we looked at the challenges with respect to building AI solutions, and we looked at the 6 responsible AI principles. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. Congratulations on completing all the content sections of this course. I'm sure you had an amazing time preparing for the AI-900 certification, and I'm sure you will do really, really well at the exam too. In this step, let's look at a few important resources that you need to check out before going to the exam. The first thing I would recommend you to check out is the homepage of the certification. If you do a Google for AI-900 Azure AI Fundamentals, you should land up on this specific page. This is the homepage of the certification, where you can go ahead and schedule your exam as well. If you scroll down, you can see the different skills which are important for this specific exam. All skills that are needed for the certification are covered as part of our course. What I would recommend you to do is to check out the skills measured and also download the exam skills outline and give it a quick read. The exam would contain different types of multiple choice questions. Type 1 would be single answer questions where there would be 2 or 3 or 4 options and there would be one right answer. And there would be type 2 questions where there would be multiple answers. So you will have 5 or more options and you will be requested to choose 2 or more right answers. Remember that there is no penalty for wrong answers. So feel free to guess if you do not know the answer. The exam should contain about 40 questions, and in total you should have about 60 minutes. This is more than sufficient time as far as this exam is concerned. And if you have went through the entire course, the exam also should be pretty easy. I have more than 10 cloud certifications at this point, and AI-900 was the easiest among them. As usual, this certification exam also gives you the option for marking questions for future consideration, and you can review them before final submission. So if you are confused about a specific question and you see that you're spending a lot of time on it, you can mark the question for future consideration, and just before your final submission, you can review it. As soon as you complete the exam, the result would be immediately shown. All in all, if you have went through the entire course, this specific certification exam must be very easy. Make sure that you review the presentation once before the exam, and I'm sure you do pretty well at the exam. I'll see you in the next step. Welcome back. Congratulations on completing this course. I'm sure it was an incredible learning experience. Let's clap for you. You put your best foot forward to achieve the AI-900 certification. Make sure that you prepare well, and here's wishing all the luck from the team here at In 28 Minutes. Now, before you go, remember that a lot of effort goes into preparing these courses. So do not forget to recommend the course to your friends, and do not forget to leave a review. Reviews are really, really important, and if you want this course to be successful, do not forget to leave a review. We make courses to earn a lot of money, but another important goal is to be part of your success. Helping you succeed is how we define our success. So if you have any success stories to share them with me and also other learners in Q&A. I'm really excited to have had the privilege of being part of your learning journey with Azure and machine learning. I'm sure our paths would meet again in the near future. Until then, here's bye from Ranga at In 28 Minutes.